Okay, so let's start. Yeah. So firstly, let's go to the important diagrams. So I hope everybody knows about these diagrams, and most importantly, what are the questions for the diagram. Most of you I know are just practicing the diagram without knowing the names of the diagram. So you should know names of the diagram. These are the very important diagram list. I'll show the diagram also now. Yeah. So these are the diagrams. So firstly, you can see, okay, the simple electric circuit here. You can see simple electric circuit here. Then you can see, okay, then the next side. Once check okay. So next, immediately next to it, you can see resistance, resistors in series and parallel. Okay. So, and you should be very, when you draw these diagrams, the direction of current is very important. Directions ಗಳು ಇರಲೇಬೇಕು. Directions ಗಳನ್ನ ನೀವು ಪ್ರಾಕ್ಟೀಸ್ ಮಾಡಿ. ಅಂದ್ರೆ you draw it, there are directions. And the signs, symbols, plus and minus. Most of you make mistake when you draw. You can see here the battery part. You will do a lot of mistakes when you do the battery part. So practice here the battery part, like how, the long line, the short lines, practice here. Next, the symbols and components, that it is asked in all the preparatories, it is there in all the model papers. So it is a definite question. Either he can give a diagram and ask you the name of it, or give the name and ask the diagram. So practice it thoroughly. Okay. Next is here, you can see the middle diagram, which is very important, which most of you do not know properly. So that is a diagram of magnetic field lines around a straight current carrying conductor. Question ಏನು ಕೇಳ್ತಾರೆ exam ಅಲ್ಲಿ? They will tell, draw a magnetic field lines around a straight current carrying conductor. So this is the diagram you should be doing. This is the diagram that is there, the middle. That is the diagram you will be doing. Okay. So next you can see the last, no, the two prisms. You can see. So this, most of you know, it is spectrum recombination of white light, or Newton's experiment. Okay. So these are the 6 essential, very important diagrams. For and the diagram ne keltar draw madake. They will tell you to draw the diagrams. So these are the diagrams which will be asked to draw. Okay. They can also ask a diagram based question, but purely diagrams, these are the list of purely diagrams that will be asked. Okay. Let me go to the next one. Yeah. So coming firstly to electricity chapter. This is the overview of the chapter. And this year we know we have blueprint. Based on blueprint, I have prepared this, and based on observing all our, our preparatory and model papers, these are the outcomes. Like this is how the question paper will be. 1 mark, there are 2 questions in electricity. What they will ask? They will ask SI units, symbols and components, and definitions. Okay, it can be asked for 2 questions, 1 marks. Next, for 2 marks, only 1 question they will ask, and that is very clear. It will either be, it can be what, Ohm's law, it can be Joule's law, it can be a question based on resistivity table, a Gue reason type of question. Okay, so 2 marks question. Next 4 marks is, if you see most of the model paper, all your preparatory, it is 100% sure it will be a numerical for 4 marks. So this is the outcome of your, what do you say, this is what that is there in your, that you have to follow in your electricity. Now let me go one by one. So ಕಾಣಿಸ್ತಾ ಇದೆಯಲ್ಲ ಸರ್ ಎಲ್ಲ clear? Okay. So next is here symbols and quantities. This most of you know. You should know all the quantities. You should know all the SI units. So this is okay. So you should know all this, especially now. Till now they were not asked electric charge. They were not asked. Okay. So make sure you know what is the SI unit of electric charge. Cc, charge coulomb, current ampere, potential difference is volt, resistance ohm, resistivity, and power. power of lens and power. Power of lens is diopter. It is from light chapter, but still I've added here. So if you see all the preparatory paper, they was the SI units. Let me go to the next one. Okay. Okay. So factors affecting resistance of a conductor. This most of you know. So here you need to understand what they'll do is little, what do you say? Little changes. Now, for example, you can see two diagrams here, right? A red color wire and a black wire. If you see the red wire, it is little length. If you see, okay, if you see this red wire here, okay, and the black wire here, and the bulbs here, if you see, the red one is glowing more. That is because, okay, the length is very much less. Okay, the length is very much less. Short wire, they written already. See, short wire, length is less, it will glow more. Okay, why? More the length, more the resistance. So if you see the next one, thickness. If you see here, thin wire and thick wire. In thick wire, it is glowing more. So meaning more current can pass. Why more current can pass? Because the resistance will become less. More the area of cross section of the wire, less the resistance. Okay. Next, material. It depends on material also. Copper, iron, gold, silver, and temperature. Okay. Temperature, in Ohm's law only we write now at constant temperature. This works. Okay. Ohm's law works because of at only constant temperature. In varying temperatures, again it is a problem. So these are the 4 points you need to remember. Now, how they can twist this? We'll see how they can twist. Okay. So these factors I've already told, 4 points. Then the highlighted one, see the highlighted one. No need to take down. I will share all these PPTs in the WhatsApp group. If you are noting down, please stop. Please see, please hear. Now give your, just see the screen and please hear. Okay. All these notes will be given to you in your WhatsApp group. I'm sending this entire PPT. You can use this. Okay. Now red color, what I have highlighted with yellow color. What is this? Sometimes they will ask, how is resistance varying with current? How does resistance vary with length of the conductor? How does area of cross section vary with resistance? So it is same thing, like more the length of the wire, more the resistance. It is directly proportional. Next is, as the area of cross section increases, the resistance decreases. How does it vary? Inversely proportional. Area of cross section and the resistance are inversely proportional. Meaning what? If something grows, something falls down. If area of cross section increases, the resistance falls down. Directly proportional. What is the meaning of directly proportional? Both grows together. Both will grow. As length increases, resistance increases. But here, inversely proportional meaning, if your area of cross section increases, what happens? Automatically your resistance will decrease. So when they ask this, you have to write this statement. Okay. How does it vary? So how does area of cross section vary? It varies inversely. And you just need to give that, like as area increases, resistance decreases. Okay. So these things, please remember. Okay. Next. Yeah. Next, very important thing. This table. No need to buy at this table. Just observe the table properly. Okay. Just observe the table properly. So you can see here multiple materials and resistivity. Multiple materials and you can see some resistivity. 1 second. Okay. Yeah. So I have enabled the chat box. Please only chat if something is not visible. Something happens, you can just put it in the chat box. Okay. So anyhow, so now I think again it is the screen is shared. Yeah. Now if you see, this is a table. Okay. What is this? What is this table about? This is about resistivity. What is resistivity? How it is different from resistance? Both are same only. Both are same. But resistivity, if you tell resistance, Given on copper wire, tell resistance. Oh, you told some ohms, but for what length? For what length? So resistivity will tell you for 1 meter what is the resistance. For 1 meter, what is the resistance? If you see here, lower, which has lower resistance, obviously you can see the lower resistance is silver. Silver has very less resistivity, meaning what? Resistivity is less, resistance is less. For what? For electrons, for current. Current na easy bidutte. Current will easily flow through silver. Why? Resistance is less, 10 to the power minus 8. Copper, slightly better. But silver we cannot use because it is very costly. We are using copper and aluminium. Why? Copper and aluminium. They will ask this due reason question. Why are we using copper and aluminium? Because copper and aluminium, okay, so they are economical. It's not cheaply antala bird bulls per. They are economical and they have very less resistivity and more conductivity. See, it is again inversely proportional. Less resistivity, more conductivity, inversely proportional. Less resistivity, more conductivity. Now, if you see insulator, paper tholi, 10 to the power 12, the resistivity is so much more, so much more. So, what happens to the conductivity? It falls down. Inversely, one ಬೆಳೆದ್ರೆ ಒಂದು ಕಡಿಮೆ ಆಗುತ್ತೆ. This is resistivity, this is conductivity. Okay. As the resistivity decreases, the conductivity increases. It is inversely proportional. So now, if you understood this, they will ask a table-based question. I will just present you two questions. First question here, okay? There are three materials, X, Y, and Z. Okay, X, Y, and Z, three materials are there. And resistivity values are given. Okay, one is -9, one is -5, and one is -27. Okay, now tell me, arrange the samples in increasing order of their conductivity. Increasing order of conductivity. And second question is, which of this is the best conductor? And lastly, which is best insulator? Onande barana. Go to the concept again. More, okay? More the which has more resistivity will be bad in conductivity. Correct? Very sorry, I'll just go. Yeah. Now, which has more resistivity, bad in conductivity. So first we'll answer which is best conductor. Conductor best agbeku andre, okay, the resistivity should be very much less. ಯಾವ್ದು ಕಡಿಮೆ ಇದೆ? X, Y, Z. It is Z, 10 power minus 27. Very less resistivity means very less resistivity, more the conductivity. For best conductor, I will be using a Z. For best insulator, which I will use? Insulator ಅಂದ್ರೆ ಕರೆಂಟ್ ಪಾಸ್ ಆಗಬಾರದು. ಯಾವ್ದನ್ನು ಯೂಸ್ ಮಾಡಲಿ? X, Y, Z. Obviously, the lesser one. It is Y1. Why? Because 11.1 10 power minus 5. Okay. So, very less conductivity if you see. ಅದು ಇದ್ದಿದ್ರಲ್ಲಿ very less. So, obviously, the it will be a best insulator because current cannot go in it. So, which is less? ಇದರಲ್ಲಿ ಯಾವುದು ಕಡಿಮೆ ಅಂದ್ರೆ it is 8 into 10 power minus 27 is very much less. Very much less conductivity, less, what do you say? This is very, your resistance is very less. So the conductivity will be more. So for best conductor, which is the best conductor? It is Z, which is the best insulator, it is Y. Now arrange in increasing order of the conductivity. Which is good at conductivity? You tell me. Z will be good at conductivity, first place. Second place goes to X, third place goes to Y. In first place, second place, third place ಕೊಟ್ರೆ ಯಾರು ಬೆಸ್ಟ್, ಯಾರು ಕರೆಂಟ್ ಚೆನ್ನಾಗಿ ಪಾಸ್ ಮಾಡ್ತಾರೆ? Z ಚೆನ್ನಾಗಿ ಪಾಸ್ ಮಾಡ್ತಾರೆ. It is very good conductivity, less resistivity, very good conductivity. So Z is first place, second place goes to X, third place goes to Y. Next, again one more question you can see, 13th one. Okay, resistivity of A, B, C are given. Which material can be used as conductor? Which material can be used as insulator? Justify your answer. Okay, this is sub question A. Sub question B is something else, not related to it. Don't worry. So first one, for the sub question 13A, now you only can answer. So which can be used for conductor? For conductor, very less resistivity hudukbeku. B, very less resistivity, very good conductor. Insulator ಯಾವುದು? ಜಾಸ್ತಿ resistance ಇರೋದು, resistivity ಇರೋದು ಯಾವುದು? 10 power 12. It has very much high resistivity, very much high opposition for electricity. Therefore, it is very bad for conductivity. It is good for insulator. Again, illu kelbodu. First, second rank kodi. ಫಸ್ಟ್ ರ್ಯಾಂಕ್, ಸೆಕೆಂಡ್ ರ್ಯಾಂಕ್, ಥರ್ಡ್ ರ್ಯಾಂಕ್ ಕೊಡಿ ಅಂದ್ರೆ ಫಸ್ಟ್ ರ್ಯಾಂಕ್ ಯಾರು ಕೊಡ್ತೀನಿ ಕಂಡಕ್ಟಿವಿಟಿಯಲ್ಲಿ. ಬಿ ಸ್ಟ್ಯಾಂಡ್ಸ್ ಫಾರ್ ಬೆಸ್ಟ್ ಕಂಡಕ್ಟಿವಿಟಿ, ದೆನ್ ಎ, ದೆನ್ ಸಿ. Okay, this is very important for you to understand. Okay, no need to buy at the values, understand it, very simple. It is inversely proportional. As resistivity increases, conductivity decreases, that's all. If you understand this and understand these questions, you can very clearly answer. 2 marks you get, 2 marks ಬರುತ್ತೆ ಇದೆಲ್ಲ ಸಬ್ ಕ್ವಶನ್ ರೀತಿ 2 marks. Okay, next Ohm's law. You all know what is Ohm's law, but here what you can do is in MCQ you can give equations of Ohm's law. Which among the following is not Ohm's law equation? ನಿಮ್ಗೆಲ್ಲ ಗೊತ್ತಿರೋದೇನು, you all of you know V is equal to IR. But if you see here, okay, this triangle, if you remember, just remember this triangle. Okay, if you remember this triangle, it's very easy to study. No, V is equal to IR. First circle V is put circle, V is equal to IR. Then I is put circle, so I and the V by R. See, it is V by R. If you want R, it is V by I. Okay, so these are 3 different versions of Ohm's law. One time 3 years back they had given in MCQ, which among the following is not the Ohm's law equation, or which among the following is a Ohm's law equation. So V is equal to IR, you know, just know the difference remembering this triangle. This is called as Ohm's law triangle. Okay, if you remember this, you can be asked 1 mark question. Next, all of you know Joule's law of heating, 100% question. And here they will ask what is the equation, what is the mathematical mathematical equation for Joule's law of heating. It is H is equal to I square RT. Okay, you have to write that. And applications, write 2 applications of Joule's law of heating they will ask. So iron box, geyser, oven, toaster, anything, any appliances which is working on which will give you heat. Heating devices, heat na produce ಮಾಡೋ devices. ಐರನ್ ಬಾಕ್ಸ್ ಬಿಸಿ ಆಗುತ್ತೆ, ಗೀಸರ್ ಅಲ್ಲಿ ಬಿಸಿ ಆಗುತ್ತೆ, ಓವನ್ ಅಲ್ಲಿ ಬಿಸಿ ಮಾಡಕ್ ಯೂಸ್ ಮಾಡ್ತೀವಿ, ಟೋಸ್ಟರ್ ಬಿಸಿ ಮಾಡಕ್ ಯೂಸ್ ಮಾಡ್ತೀವಿ. ದೀಸ್ ಆರ್ ಕಾಲ್ಡ್ as heating devices. Okay, all the heating devices are, the basic idea behind them is your Joule's law of heating. And sometimes they will ask what is the principle behind fuse. Fuse ಹೆಂಗ್ ವರ್ಕ್ ಆಗುತ್ತೆ ಮತ್ತೆ Joule's law of heating. Okay, so about Joule's law of heating, so many things you have to remember. Okay, it is very easy, nothing to by heart, just understand. So science, again I'm telling, if you're by hearting, it is waste. Try to understand the concepts, interlink the concept, connect the concept, then it is very easy to score well. Okay, next, parallel and series connection. Okay, you know what is parallel connection, what is series connection? Back to back, serial set, back to back, one after other. So now here one important question you'll ask. In series connection, what is same, what is different? What is same, what is different? What is same is same current will flow. Only one current, because current has no deviations here. It will go for R1, then go to R2, then go to R3. ಹೋಗ್ತಾನೆ ಇರ್ತಾರೆ, ಎಲ್ಲೂ ಡಿವಿಯೇಟ್ ಆಗಲ್ಲ, ಬೇರೆ ದಾರಿಗಳಿಲ್ಲ ಕರೆಂಟ್ಗೆ, ರೆಸಿಸ್ಟರ್ಸ್ ಬೇರೆ ಇಲ್ಲ. Current will go in a straight path. What will change? The potential difference will change. The potential difference for each one is different here. Okay, remember this. In series connection, current is same, potential difference is different. Then you know, in series connection, if you make something in series, if it is 2 ohm, 3 ohm and 5 ohm, if you join them, what will happen? It will become 10 ohms, R1 plus R2 plus R3. If you add everything, okay, R1 plus R2 plus R3, if you add everything, it will become very much more. So when you add resistors in series, back to back, separate ಆಗಿದ್ದಾಗ ಚೆನ್ನಾಗಿತ್ತು, ಸ್ವಲ್ಪ ಕಡಿಮೆ ಇತ್ತು ರೆಸಿಸ್ಟೆನ್ಸ್. When you put into series, suddenly it will become more. Okay, so that is why we do not use them in a regular setup. We do not use series connection. Then why we again do not use? Because you know, in R1, in this diagram, if R1 is not working, what will happen to the current? It will not go forward. ಅಯ್ಯೋ ದಾರಿ ಇಲ್ಲ, ಮುಗ್ದೋಯ್ತು, ಕಟ್ಟಾಗೋಯ್ತು, R1 ನಲ್ಲಿ ಕರೆಂಟ್ ಕಟ್ಟಾಗೋಯ್ತು, ಮುಂದೆ ಹೋಗೋದೇ ಇಲ್ಲ, ಕರೆಂಟ್ ದಾರಿ ಇಲ್ಲ, ಕರೆಂಟ್ has no other part to go. So even R2 and R3 will not work. Even if R2 and R3 is very good, if there are 3 bulbs, R2 bulb and R3 bulb, they are very good, R1 bulb is gone, it is dead, then all the 3 bulbs will be dead. So that is the problem with what series connection. Then how to change it? How to change it? We'll see. So parallel connection. What is parallel connection? You know, on the next, again, very important thing. What is same and what is different? In series connection, what is same? In series connection, current is same, potential different is different. But here, In parallel connection, if you see the diagram, it is very clear. Current has three paths. ಮೂರು ದಾರಿ ಇದೆ. ಆರಾಮಾಗಿ ಹೋಗುತ್ತೆ, ಅಲ್ಲಿ ಇಲ್ಲಿ ಅಲ್ಲಿ ಇಲ್ಲಿ ಹೋಗುತ್ತೆ, ಮೂರು ದಾರಿಲಿ ಹೋಗುತ್ತೆ. ಪೊಟೆನ್ಷಿಯಲ್ ಡಿಫರೆನ್ಸ್ ಸೇಮ್ ಇದೆ. ಪೊಟೆನ್ಷಿಯಲ್ ಡಿಫರೆನ್ಸ್ ಇಸ್ ಸೇಮ್. Potential difference is same. Current is different. Then even if one component fails, now R1 bulb, R2 bulb, R3 bulb, R1 bulb is failed. What happens to R2 and R3? Still it will work. Why? Because there is different paths. Current ಹೋಗುತ್ತೆ R1 ಗೆ, ದಾರಿ ಇಲ್ಲ. Okay, ಬಿಡು ಬೇಡ. I have still R2 and R3 path. It will say ನನಗೆ I have R2 path and R3 path. I will go, no problem. So even if one component fails, that's okay. Current will easily pass through other component. And very important last point you can see here. Even in numericals, this idea you should have. Okay. Total resistance is always lesser than the least resistance. What is the meaning? If at all, R1 is 2 ampere, R2 is 3 ohms, 2 ohms, 3 ohms and 4 ohms. If at all, 2, 3 and 4 ohms. If I connect in series, what will happen? Everything will get added up. 2 plus 3 plus 4, it will become 9 ohms. But in series connection, in parallel connection, it is 1 by 2 plus 1 by 3 plus 1 by 4. If you do the calculation and see, you will get an answer less than 2. Kadme, among this R1, R2, R3, which is the worst one, which is the least resistance one, it is 2 ohms. The answer will be less than 2 ohms. 2 ohms ಗಿಂತ ಕಡಿಮೆ ಇರುತ್ತೆ. ಸೊ ಇವನ್ ಇನ್ ಯರ್ ನ್ಯೂಮರಿಕಲ್ಸ್ ದಿಸ್ ಐಡಿಯಾ ಯು ಶುಡ್ ಹ್ಯಾವ್. ಸೊ ಮೊನ್ನೆ ಕೊಟ್ಟಿದ್ರು ಪ್ರಿಪೇಟರಿಯಲ್ಲಿ, ತುಂಬಾ ಜನ ರೆಸಿಪ್ರೋಕಲ್ಲೇ ಮಾಡಿಲ್ಲ, ಆನ್ಸರ್ ಬಂದಿರೋದನ್ನೆಲ್ಲ ಮಾಡ್ಬಿಟ್ಟಿದ್ದೀರಾ. When you get an answer, especially in parallel connection, the final answer should be lesser than the least one for parallel connection. That is why we use parallel connection and not series. Okay, so this you should definitely know the difference between series and parallel connection, correctly understand. Okay, so this obviously I'm telling again, I'll give this PPT. I'll also share one notes that I made. Okay, just 7 pages of notes, everything is covered there. Okay, so try to understand. So these are the points. It will be definitely asked: parallel and series resistors. Next, what are the 3 equations of power? Keltare, write the 3 equations of power. All of you know P is equal to VI or IV. You should also know it is also equal to I square R. It is also equal to V square by R. Sir, ideng ಬಂದ್ಬಿಡ್ತು? ಇದೆಂಗೂ ಬಂದಿಲ್ಲ. We just know Ohm's law. What is Ohm's law? V is equal to IR. I'm just replacing here. See in the red one here. Okay, in the red one here, I am keeping as it is. I'm replacing with V. So what happens? V is equal to IR. So I into I square R. Therefore, P power is also equal to V into I. It is also equal to I square R. How did we get V square by R? It is again same. I na ange ಉಳಿಸ್ಕೊಂಡು V na change ಮಾಡಿ. What is V? Sorry, I na change, V na ange ಉಳಿಸ್ಕೊಳ್ಳಿ, I na change ಮಾಡಿ. What is I? If you see Ohm's law, V is equal to IR, then I andre V by R. If you replace V by R in place of I, V into E, V into V, it is V square by R. Okay, so these are the 3 equations. You just remember the 3 equations of power. P is equal to VI, P is equal to I square R, P is equal to V square by R. These are the 3 equations of power. Okay, how did you get the other 2 equations? By Ohm's law. If you know one, other 2 you can just apply and find, or just remember these 3 equations of power. Okay, lastly, instruments and uses. What is battery? What is ammeter? What is voltmeter? What is variable resistance? What is rheostat? You should know all of them. And how are they connected? What is ammeter? You know that is, it is used to measure electric current. Voltmeter is used to measure potential difference or voltage. How are they connected? Ammeter is always connected in series. Voltmeter is always connected in parallel. Okay, so this you can see in the recent preparatory for 1 marks they have asked. Correct. So this is how you should know all these instruments. This is there in textbooks. Variable resistance and rheostat also you should know. Okay, so these are the 5. And what is battery? Battery in the energy baralla. Battery in the energy baralla, electrons baralla. Battery will just create that potential difference so that the electrons will move. ನೀರ್ ಬೇಕು ನಿಮ್ಮ ಮನೆಗೆ ಅಂದ್ರೆ ಟ್ಯಾಂಕ್ ತಗೊಂಡೋಗಿ 3ನೇ ಫ್ಲೋರ್ ಅಲ್ಲಿ ಇಡಬೇಕು. If you want water to your ground floor, then you have to take the water and keep it in the 5th floor. Okay, your water tank. Then that is called as potential difference. Water will easily come due to gravity. Battery kuda, it will create the difference of electrons. If here there is 100 electrons, here it will keep 10 electrons. So what will happen in the nature, everything wants to be balanced. So electrons 100 to 10, it will try to come. 40 will come here, it will become 50, it will become 50. So by the process of moving, no, you'll get electricity. So why we need battery? Battery is used to maintain potential difference. So this one you need to correctly understand and read this table. Next, this already I told what is ohm meter, I told say ohm meter, voltmeter, fuse. This is very important. Fuse andre eno munde bartini, but matte heltini. Fuse is like a security guard. Who is security guard? ನಿಮ್ಮನೆ ಯಾಕೆ ಸೆಕ್ಯೂರಿಟಿ ಗಾರ್ಡ್ ಬೇಕು? ಕಳ್ಳ ಬಂದ್ರೆ, ಇನ್ಯಾರೋ ಹೊಸಬ್ರು ಬಂದ್ರೆ ಎಲ್ಲ ಚೆಕ್ ಮಾಡಕ್ಕೆ ಸೆಕ್ಯೂರಿಟಿ ಗಾರ್ಡ್ ಬೇಕು. ಹಂಗೆ ಕರೆಂಟ್ಗೆ for my laptop, I just require 5 amperes of electricity. I just require 5 ampere of electricity. If at all 10 ampere comes, what will happen to my laptop? It will get destroyed. The wires will get burnt. So then who will check? There is one security guard. He is called as fuse. What he will do? Immediately 5.1 ampere current comes, gone. What will gone? The fuse will burn itself. It will sacrifice itself so that my laptop is not destroyed. It is like a security guard who will sacrifice himself. Okay. Then how we should place? Is the person who will sacrifice is a primary person. Can you keep it in parallel? If you keep in parallel, current will find different paths. We want only one path. Raja marga beko. ಆಯ್ತಾ ಒಂದೇ ಮಾರ್ಗ ಬೇಕು. That is your fuse. So fuse is connected always in series. Before the current comes to an electricity meter, it comes to fuse. First to fuse bando. If you're not paid your electricity bill, they'll first take your the fuse from your home, because fuse is a doorway, the first primary doorway. So fuse is always placed in series. And about fuse, I already told you what is the principle behind fuse. It is very simple. It is a Joule's law of heating. Okay. So now let's go to the next slide. Next chapter, magnetic effects of electricity, where many of them do not know the basic concepts properly. Firstly, these are the rough outcome. So what are they asking? No 4-mark question. Only 1 mark, 2 mark and 3 mark question. 1 mark, very simple question they will ask. It will be based on solenoid, magnetic field lines, patterns. 2 marks, again very simple. They're always asking about overloading, precautions, measures, earth wire or diagram. What is that diagram? I told you already. Only one diagram from this chapter which they'll ask to draw. That is your draw a field lines around a straight current carrying conductor. Okay. Only one diagram they will ask. 3 marks. 100%. Okay. It is about the activity. Activity it is asked. There are 2 very important activity. One is draw the field lines around a bar magnet using the compass needle. That activity I'll explain. I'll show you. Next, one more activity. Experiment to show current carrying conductor when kept in a magnetic field experience a mechanical force. Then one more about solenoid, they might ask 3-mark question, where there is also a concept about a left hand rule. Okay. So 3 marks, it is very crystal clear. The activity basis alle irutte. And here in this chapter, you can expect a diagram based question and a hot. What is hot? Higher order thinking. Okay. Now let's go one by one. So firstly, all of you know the properties of field lines around a bar magnet. You take a bar magnet, nothing you can see. But if you just take a bar magnet, put a paper on it, just put some small iron fillings, then you can see a beautiful arrangement of these iron fillings which will form closed loop. They'll form closed loop. Okay. And they form a continuous loop. And they're strong near the poles. North pole, south pole, they're strong. Okay. And no field lines will cross each other. They will never cross. Why? They'll ask question. Why do not 2 magnetic field do not cross each other? Why they do not cross? Why they do not intersect? It is obvious. If it crosses, meaning at one point only there is north pole and south pole also, which is never possible. How it is possible? And one point only to have north and south pole. Okay. So this you should know the properties properly, because if you see in second preparatory, they've asked in a different way. Very simple. They asked it in a different way. They might ask in MCQ in a different way. Try to understand this properties of bar magnet. Field lines. So field lines you cannot see. You cannot see those field lines. Right? If you want to see them, you have to put the iron fillings, or we have an activity to do. I will show the activity. Now, I'll just play this video. This is the activity.
It's probably safe to say that you have a very good idea of how the magnetic field of a bar magnet looks like. But do you know the 4 important properties of magnetic field lines? To find out, let's begin by plotting some magnetic field lines. You need a pen, quantum compass, and a magnet. A magnet doesn't tell you which is the North Pole and which is the South, but we'll find out soon. Place your magnet in the middle of the page and trace around it. Place the quantum compass near the magnet. Mark the direction that the compass needle points by drawing a dot. After the first plot, move the compass so that the back of the needle lines up with the dot. Repeat this until you reach the end of the magnet. Join the points together to show a field line. I'll also draw an arrow here to show the direction that the needle was pointing in. I'll do all of the above again with another starting point. Looking at the field that we've plotted, we can figure out the 4 main properties of magnetic field lines. Number 1, magnetic field lines never cross each other. They never overlap. Number 2, they always point from the North Pole of the magnet to its South Pole. North into South, so that must mean that this is North and this is South. Number 3, they're continuous. The only reason these lines have been cropped out here is because I've simply run out of space. Number 4, where the lines are closer together, the magnetic force is the strongest. That's at the poles of the magnets.
Yeah. So now this activity is a very important activity. Why? See now, if you see, yeah.
It's probably safe to
1
say
second.
that
Yeah. So now about this activity, you should know how it is done. Very simple one is we know. You take a, you want to see the, if you want to see, if you want to obtain the magnetic field lines, just take iron fillings, put on the needle, put on the a bar magnet. You will get, but we want to draw it. How to draw it using this activity? Okay, this is the video, whatever you saw. Same, it is very simple. Take a bar magnet, keep it on a white paper, take a small compass needle, then go on, putting a point on it. So when you do this activity, you will very clearly see the magnetic field lines. Okay, so this activity you should clearly know, clearly understand. Okay, so they will ask this question. It is there in model papers also. It is asked in preparatory paper also. Next, overloading. This everybody know. Yak overloading agate. Overloading is loading. Overloading is every day you get a bag. Suddenly school bag. Every day you get 10 books. Suddenly you got 20 books. Ben no. Same thing. Current. Every day you get 5 ampere, 6 ampere. Suddenly 10 amperes. Overloading. Okay. So what is overloading? Overloading. What is the reasons for overloading? Yake overloading agate. So when live wire and neutral wire. Inside a wire, there will be 2 wires, live and neutral, plus and minus. When plus and minus come into contact, abrupt increase, short circuit. So that short circuit will cause overloading. More current, more overloading. Suddenly, accidental hike in supply voltage. This question they'll ask. What is the potential difference between live wire and neutral wire in India? It is 220 volts. Suddenly, if there is difference in voltage, there will be overloading. And this this most of us do the mistake, connecting too many appliances to single socket. Onde socket ge ತುಂಬಾ appliances na connect ಮಾಡ್ಬಿಡೋದು. And obviously the last one, faulty appliances, faulty applications. ಅಂದ್ರೆ the appliances itself are faulty. These are the reasons. What is the solution? What are the precautionary measures? This is very easy. Precautionary measures ಏನ್ ಮಾಡಬೇಕು, ಯಾವ್ದ್ರಿಂದ ಆಗುತ್ತೆ ಅದನ್ನ ಅವಾಯ್ಡ್ ಮಾಡಬೇಕು. ಜಸ್ಟ್ ಅವಾಯ್ಡ್, make sure that live wire, neutral wire do not touch each other, and there will be proper insulating between live wire and neutral wire, and there is no faulty appliances. Do not connect too many appliances to a single socket, and use fuse. This is very important. Use fuse. Security guard itkondre ನಿಮ್ಮ ಮನೆ ಕಳ್ಳರು ಬರಲ್ಲ ಅಲ್ವಾ. So these are the points. Precautionary measures have to be taken to avoid overloading. Okay, these points you should remember. Firstly, reasons. ರೀಸನ್ಸ್ ಗೊತ್ತಾಯ್ತು. ಏನ್ ಪ್ರಿಕಾಷನ್ಸ್? ರೀಸನ್ಸ್ ಗೊತ್ತಿದ್ರೆ ಪ್ರಿಕಾಷನ್ಸ್ ನೀವೇ ಬರಿಬಹುದು, ಜಸ್ಟ್ ಉಲ್ಟಾ ಬರೀರಿ ಅಷ್ಟೇ. ಅದಕ್ಕೆ ದೀಸ್ ಟು ಕ್ವಶನ್ಸ್ ದಟ್ ವಿಲ್ ಬಿ ಡೆಫಿನೆಟ್ ಕ್ವಶನ್. ನೆಕ್ಸ್ಟ್ ಅರ್ತ್ ವೈರ್. ಇಲ್ಲಿ ಡಯಾಗ್ರಾಮ್ ಇದೆ ನೋಡಿ, ಗ್ರೀನ್ ಕಲರ್ ವೈರ್ ನಮ್ಮ ಮನೆಯಲ್ಲಿ ಇರುತ್ತೆ. ಎಲ್ಲಿ ಯೂಸ್ ಮಾಡ್ತೀವಿ? ಓನ್ಲಿ ಅಪ್ಲಯನ್ಸಸ್, ಓನ್ಲಿ ಅಪ್ಲಯನ್ಸಸ್ ವಿಚ್ ಐ ಹ್ಯಾವ್ ಎ ಮೆಟಲ್ ಬಾಡಿ. ಫ್ರಿಡ್ಜು, ಟಿವಿಗೆ 3 ಪಿನ್ ಇರಲ್ಲ, 2 ಪಿನ್ ಇರುತ್ತೆ. ಫ್ರಿಡ್ಜ್ಗೆ 3 ಪಿನ್ ಇರುತ್ತೆ. ಓವನ್ಗೆ 3 ಪಿನ್ ಇರುತ್ತೆ. ಫಾರ್ ಐರನ್, ಎಲೆಕ್ಟ್ರಿಕ್ ಐರನ್, ಯು ಹ್ಯಾವ್ 3 ಪಿನ್. 3 pin. Why this 3 pin? Why the topmost pin that is there, which is of little thicker one? Why that pin is there? From that wire you don't get electricity. You don't get electricity from that wire. Current goes out from that path. It is like a path where current can go out. Sir, why should current go out? Basically, we want current to come inside the appliances, right? Then why it should go out? Why it should go out? Because I told you, all these instruments I told you, okay, whether it may be refrigerator, whether it may be oven, whether it may be iron, all this have a metal body. Metal body. Okay. So what happens if metal body is there? Metal body, there is chances of leakage of electricity. Leakage of electricity. Leak ಆದ್ರೆ ನೀವು ಮುಟ್ಟರೆ ಶಾಕ್ ಹೊಡೆಯುತ್ತೆ. Okay. So last week I went to gym. I am in a treadmill. Suddenly ಶಾಕ್ ಹೊಡಿತಾ ಇದೆ. ಏನಕ್ಕೆ ಅಂತ ನೋಡ್ರೆ ಅರ್ಥಿಂಗ್ ವೈರ್ ಇಲ್ಲ, ಅರ್ತ್ ವೈರ್ ಇಲ್ಲ, ಶಾಕ್ ಹೊಡಿತಿದೆ ನನಗೆ. ಮೀನ್ಸ್ ದೇರ್ ಇಸ್ ಲೀಕೇಜ್. ಲೀಕೇಜ್ ವೈ? ಇಟ್ ಇಸ್ ಎ ಮೆಟಲ್ ಬಾಡಿ, ದೇರ್ ಇಸ್ ಎ ಕರೆಂಟ್ ಲೀಕೇಜ್. ಮುಟ್ರೆ ಶಾಕ್ ಹೊಡಿತಾ ಇದೆ. ಸೊ ಹೌ ಟು ಅವಾಯ್ಡ್? ಕರೆಂಟ್, ಇಫ್ ಯು ಗಿವ್ 2 paths. ಫಾರ್ ಕರೆಂಟ್ ಯು ಗಿವ್ 2 paths. Okay, one, a very low resistance path, a good material of wire which has less resistivity. You use silver or copper, silver copper wire which is very good quality. 2 paths. One you give good quality wire, when you give bad quality wire, which current will choose? Current will choose good quality path. So what we do is this green color wire which is used for earth wire, no, it is very high quality wire. It has low resistance path, high conductivity. Current leak ಆದ್ರೆ ದಾರಿ ನಿಮ್ಗೆ ಶಾಕ್ ಹೊಡೆಯಲ್ಲ, it will go to ground ಹೋಗ್ಬಿಡುತ್ತೆ. Okay, so this is the points. Whatever I told, you can write on your own, or you can see here. Okay, it provides a low resistance path. There might be leakage of current due to metallic body. Okay, so make sure to bring all the current to the ground. Okay, we use so that we do not get shock. So electric earth wire is provided. Okay, so about earth wire, I feel they'll ask this time. It is not asked anywhere in the preparatory. In final exam, make sure in all the model paper and preparatory papers, okay, whichever, just they ask once. ಬಿಟ್ಬಿಟ್ಟಿದ್ದಾರೆ, ಒಂದ್ಸತಿ ಕೇಳಿ ಬಿಟ್ಬಿಟ್ಟಿದ್ದಾರೆ. ನೀವೇನ್ ಮಾಡ್ತೀರಾ? ಒಂದ್ಸರಿ ಕೇಳಿ ಬಿಟ್ಟಿದಾರಲ್ಲ, ಮತ್ತೆ ಕೊಡಲ್ವೇನೋ? No, you first target those which are not asked. There are many questions in model paper which are still not asked in your preparatory. ಅದೆಲ್ಲ ನಿಮ್ಗೆ ವೆಯ್ಟ್ ಮಾಡ್ತಾ ಇದೆ ಫೈನಲ್ ಎಕ್ಸಾಮ್ಗೆ. ಸೊ ಡು ನಾಟ್ ಲೀವ್ ಎನಿ ಕ್ವಶನ್ಸ್. Try to understand every question that is there in model and preparatory. ಯಾವುದನ್ನು ಕಾಂಪ್ರಮೈಸ್ ಇಲ್ಲ, no compromise. Okay, so anyhow, we'll go to the next question. Right hand thumb rule, very important, very important. If you want to solve application, you may see very simple alla, ಆದರೆ to solve some application based question you have to understand right hand ಇಟ್ಕೊಳ್ಬೇಕು. ನಾನೇ ಕನ್ಫ್ಯೂಸ್ ಮಾಡ್ಕೊಂಡು ತುಂಬಾ ಸತಿ ಲೆಫ್ಟ್ ರೈಟ್ ಇಟ್ಕೊಂಡು ಕನ್ಫ್ಯೂಸ್ ಮಾಡ್ಬಿಟ್ಟಿದ್ದೀನಿ. ರೈಟ್ ಹ್ಯಾಂಡ್ ಥಂಬ್ ರೂಲ್. ಸೊ ವಾಟ್ ಈಸ್ ರೈಟ್ ಹ್ಯಾಂಡ್ ಥಂಬ್ ರೂಲ್? ಓಕೆ, ನೌ you should know one thing very clearly. Okay, what we know is, in a magnet, around a magnet there is a magnetic field. ಇದು ಯಾರು ಬೇಕಾದ್ರೆ ಹೇಳ್ತಾರೆ, ಒಂದು ಚಿಕ್ಕ ಮಗುನು ಹೇಳುತ್ತೆ. ಬಟ್ ಆರೆಸ್ಟೆಡ್ ಅಂತ ಒಂದು ಸೈಂಟಿಸ್ಟ್ he took a conductor. This pen is a conductor and current is passing. Pen is a conductor, current is passing. Suddenly he got a compass needle to it. By chance he got a compass needle. He had a shock. What shock? That compass needle is moving. Compass needle yak move aguttappa illi? If I get a compass needle near a magnet, it will move. That is a common sense. But I'm getting to a conductor where current is passing. Why it is moving? That means there is a magnetic field around this conductor. How magnetic field? That is the principle. That is why the chapter name is magnetic effects of electricity. Wherever there is electricity, there is a magnetic field. ಇದು ಕಂಡಕ್ಟರ್ ಆದ್ರೆ, ಇದು ಕಾಪರ್ ಆಗಿದ್ರೆ, ಇದಕ್ಕೆ ವೈರ್ ಕನೆಕ್ಟ್ ಮಾಡ್ಬಿಟ್ಟು ಬ್ಯಾಟ್ರಿ ಕನೆಕ್ಟ್ ಮಾಡ್ಬಿಟ್ರೆ, ಅರೌಂಡ್ ದಿಸ್ there will be a magnetic field. Can you see that magnetic field? You cannot see. If you want to see, what you should do, just keep paper like this, put some iron fillings. What will happen? You'll get a concentric shape, concentric circular shape of iron fillings. Okay, now you understood this. Okay, but why do you want right hand thumb rule? Because what is the direction of magnetic field? Clockwise or anti-clockwise? ಯಾವ ತರ ಹೋಗ್ತಾ ಇದೆ ಅಂತ ತಿಳ್ಕೊಳ್ಳಕ್ಕೆ ರೈಟ್ ಹ್ಯಾಂಡ್ ಥಂಬ್ ರೂಲ್ ಬೇಕು. ವೆರಿ ಸಿಂಪಲ್ ಇಟ್ ಇಸ್. ಹೋಲ್ಡ್ ಯರ್ ರೈಟ್ ಹ್ಯಾಂಡ್ such that the thumb indicates the direction of current and the fingers wrapped will indicate the direction of magnetic field. Now they'll ask, why do you want right hand thumb rule? Why do you want right hand thumb rule? We want right hand thumb rule to find the direction of magnetic field lines ಕಂಡುಹಿಡಿಯಕ್ಕೆ right hand thumb rule ಬೇಕು. Okay, so now this is a right hand thumb rule. Now we'll solve some questions. Okay, now this is very important concept. Clockwise anti clockwise ಯಾವಾಗ ನೋಡು ಕನ್ಫ್ಯೂಷನ್, ಏನಿದು ಅಂತಾನೆ ಗೊತ್ತಾಗ್ತಿಲ್ಲ. ತುಂಬಾ ಸಿಂಪಲ್. ಇಲ್ಲಿ ಎರಡು ಡಯಾಗ್ರಾಮ್ ಇದೆ ನೋಡಿ, ಅರ್ಥ ಆಗ್ಬಿಡುತ್ತೆ. ಹಿಂಗಿಟ್ಕೊಂಡ್ರೆ ನೋಡಿ, ಹಂಗೆ ನೋಡ್ತಾ ಇರಿ. ಹಿಂಗ್ ಹೋಗ್ತಾ ಇದೆ ನೋಡಿ, ಹಿಂಗ್ ಹೋಗ್ತಾ ಇದೆ. ಮೇಲಿಂದನೇ ನೋಡಿ, ಹಿಂಗ್ ಹೋಗ್ತಾ ಇದೆ. ಹೆಂಗೆ? ಗಡಿಯಾರ ದಾರಿನ, ಗಡಿಯಾರದ್ದು ಉಲ್ಟಾ ದಾರಿನ ಹೇಳಿ. ಹಿಂಗ್ ಹೋಗ್ತಿದೆ ನೋಡಿ. ಮೈ ಫಿಂಗರ್ಸ್ ಆರ್ ಲೈಕ್ ದಿಸ್. ಓಕೆ, ಹಿಂಗ್ ಹೋಗುತ್ತಾ ಗಡಿಯಾರ ನೋಡಿ, ಹಿಂಗ್ ಇಟ್ಕೊಂಡ್ರೆ ಹಿಂಗ್ ಹೋಗುತ್ತಾ ಗಡಿಯಾರ ಹೇಳಿ. ಆಯ್ತಾ? ಸೊ ನೋಡಿ, ಹಿಂಗ್ ಹೋಗ್ತಾ ಇದೆ. ಹಿಂಗ್ ಹೋಗುತ್ತಾ ಗಡಿಯಾರ? ಹಿಂಗ್ ಹೋಗಲ್ಲ ಗಡಿಯಾರ. ಏನಿದು? ಇದು ಆಂಟಿ ಕ್ಲಾಕ್ ವೈಸ್ ಡೈರೆಕ್ಷನ್. ಆಂಟಿ ಕ್ಲಾಕ್ ವೈಸ್. ಕರೆಂಟ್ ಮೇಲೆ ಹೋಗ್ತಾ ಇದ್ರೆ ವಾಟ್ ವಿಲ್ ಬಿ ದ ಡೈರೆಕ್ಷನ್ ಆಫ್ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್? ಆಂಟಿ ಕ್ಲಾಕ್ ವೈಸ್. ಕರೆಂಟ್ ಕೆಳಗಡೆ ಹೋಗ್ತಾ ಇದೆ. ಆಯ್ತಾ? ಇವಾಗ ನೋಡಿ, ಹಿಂಗ್ ತೋರಿಸ್ತೀನಿ. ಇವಾಗ ನೋಡಿ, ಇದು ಗಡಿಯಾರದ ದಾರಿ. ನನ್ನ ಫಿಂಗರ್ಸ್ ನೋಡಿ, ಗಡಿಯಾರದ ದಾರಿ. ಇವಾಗ ಗಡಿಯಾರ ಹಿಂಗೇ ಹೋಗುತ್ತೆ. ಕರೆಕ್ಟಾ? 12 o'clock, 1 o'clock, 2 o'clock, 3 o'clock ನೋಡಿ, ನನ್ನ ಫಿಂಗರ್ಸ್ ಹಂಗೆ ಇದೆ. ಸೊ ಟು ರಿಮೆಂಬರ್, you remember this UAC DC. What is UAC? Up means anti-clockwise, down means clockwise. Current ಮೇಲೆ ಹೋಗ್ತಾ ಇದ್ರೆ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಲೈನ್ಸ್ ಹೆಂಗಿರುತ್ತೆ? ಆಂಟಿ ಕ್ಲಾಕ್ವೈಸ್. ಕೆಳಗಡೆ ಹೋಗ್ತಿದ್ರೆ ಕ್ಲಾಕ್ವೈಸ್. ಓಕೆ, ದಿಸ್ ಯು ಶುಡ್ ರಿಮೆಂಬರ್. ವೈ? ಐಲ್ ಕಮ್ ಟು ಸಾಲ್ವ್ ದ ಪ್ರಾಬ್ಲಮ್ಸ್. ದಿಸ್ ಕ್ವಶನ್, ಇದು ಏನಿದು ಕ್ವಶನ್? ನೌ ಯು ನೀಡ್ ಟು ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್ ಪ್ರಾಪರ್ಲಿ ದಿಸ್ ಒನ್. ಓಕೆ, ನೌ ಸಿ, in this question it is asked the magnetic field at center of the coil. What is the magnetic field center of coil? ಎಲ್ಲ ಆನ್ಸರ್ ಬಯಾಟ್ ಹೊಡೆದಿರ್ಬೋದು, ಝೀರೋ ಬಯಾಟ್ ಹೊಡೆದಿರ್ಬೋದು. ಯಾಕೆ ಝೀರೋ ಅಂತ ತಿಳ್ಕೊಂಡಿದ್ದೀರಾ? ವೆರಿ ಸಿಂಪಲ್. ನೌ at C, okay, now current is at I1 current. I'll just put my fingers. Why? I'm using right hand thumb rule. Now I'll put my fingers around that conductor. Okay, this I1, near that I1 place. Now if I put that conductor, what happens? My fingers will go in and come outside. See, it will go in from top and come outside. Okay, so it is coming out. Remember, it is coming out where? Near I1. Okay, at the center it is coming out. Now I2, sorry, where I was, one second. Again, see confusion. I am using my left hand to see what I should use. Right hand. I1, how should I use? See, I should go in and come out. Current in the direction. Not ಮೇಲೆ ಹೋಗ್ತಿದೆ I1, ಈ ಕಡೆ it is going this side. Thumb indicates the direction of current. ಇವಾಗ ನೀವು ಹೇಳಿ, ಒಳಗಡೆ ಹೋಗಿ ಆ ಸರ್ಕ್ಯುಲರ್ ಕಾಯಿಲ್ ಒಳಗಡೆ ಹೋಗಿ ಆಚೆ ಬರ್ತೀನಿ. ಐ ಆಮ್ ಗೋಯಿಂಗ್ ಇನ್ ಅಂಡ್ ಕಮಿಂಗ್ ಔಟ್ ಸೈಡ್. ಸೊ ಇನ್, ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಲೈನ್ಸ್ ಆರ್ ಗೋಯಿಂಗ್ ಇನ್. ರಿಮೆಂಬರ್, ಇನ್. I2 ಬರೋಣ. I2 ಬಂದಾಗ, ಇಫ್ ಯು ವಾಂಟ್ ಟು ಗೋ ಟು ಸಿ, ಯು ಹ್ಯಾವ್ ಟು ಗೋ ಡೌನ್ ಅಂಡ್ ಕಮ್ ಔಟ್. One is going in, one is coming out. Going in, coming out will cancel off the magnetic field. Okay, when the magnetic fields are going in one direction, other direction it is coming out. So magnetic field will cancel off and you get zero at the center. Now we will better understand with one more question here. This question, many had confusion with this question also. Now situation 1, AB MN. Now just imagine AB. Okay, so 1 second. Okay, now I'll draw one point at I1. At the center I'm drawing one point. Okay, this point here, this point at situation T, one point here. Red color I'm marking. Okay, now they're asking, what is the question they're asking? They're asking which situation the wires will attract. Wires attract agbekanತೆ. Okay, now AB, we will see the situation 1. I'll take the right hand, and from that point where I put O, no, the center between these two lines, now I'll put my fingers like this and come out. Say I'm putting inside and coming out to hold it. To hold that AB, ಹಿಂಗ್ ಹೋಗಿನೇ ಹಿಂಗ್ ಬರ್ಬೇಕು. So I'm going inside. What? I'm going inside. Remember, I'm going inside. Next, for MN, ಇಲ್ಲೂ ಏನ್ ಮಾಡಬೇಕು? What I should do? See, I'm going and coming outside. See here, ನಾನು ಮೇಲಿಂದ ಹೋಗಕ್ಕಾಗಲ್ಲ, ಹಿಂಗಾಗೋಗ್ಬಿಡುತ್ತೆ. Now my current direction is this only. So I should, if I want to hold that, see, if I want to hold this, I have to go like this. Okay, so means what? I am going and coming out. See, this is coming out. Top ಅಲ್ಲಿ ಏನಾಗಿತ್ತು ಆಯ್ತಾ? So for top, see, I cannot go here also. It is like this. See, I have to go inside that O point, and here also it is not inside. I'm coming outside the O point. In top, for AB, okay, this is I1 current. For AB, what I should do? See, I'm going inside and coming out, going inside and coming out to that O point. MN point, what is happening? I am coming down and coming out for that O point. So one is going in, one is coming out. So what is the magnetic field? What is the field, magnetic field there? It is zero. Zero ಆದ್ರೆ ಏನಾಗುತ್ತೆ? ಆಚೆ ಈಚೆ in AB and MN, outside AB and outside MN, there is still magnetic field that will make them push inside. They will attract each other. Situation 2, you see, situation 2, AB is going like this. Now what is the magnetic field lines? It will come outside. See, it will come outside. MN, now it is, sorry, I am again right and left confusion. Wait, this one, see, this is my right hand. For AB, I am holding this. It is going inside. That O point, it is going inside. For MN is like this. So now current, my thumb is there. Is now again inside. Both inside I should go. In this case, both you are going inside. So still magnetic field lines will be there. They will not allow it to attract. It will repel. So in situation 1, since the, you can remember very simple. ಇಷ್ಟೆಲ್ಲ ನಿಮ್ಗೆ ಅರ್ಥ ಆಗಿಲ್ಲ ಅಂದ್ರೆ ತುಂಬಾ ಸಿಂಪಲ್ ಗ್ಯಾಪ್ ಮಾಡ್ಕೊಳ್ಳೋದು, ವೆರಿ ಸಿಂಪಲ್. Both current going in same direction. If the currents are going in same direction, they will attract. Okay, if the current is going in opposite direction, they will repel. This, if you remember, repel, or they will not attract each other. This, if you remember. And here I'm if I was in the real in front of you, I would have made you do that, but I hope you understood. Still, if you not understood, I made one 30 minutes video, my latest video in my YouTube. There are clearly explained only these questions. Okay, you can see again and try to understand. Don't worry. ನಿಮ್ ತುಂಬಾ ಅರ್ಥ ಆಗಿಲ್ವಾ ಸರ್, ಇದೇನಿದು ಹಿಂಗೆ ಮೇಲೆ ಕೆಳಗಡೆ ಅಂತಿದ್ದೀರಾ ಅಂದ್ರೆ ತುಂಬಾ ತಲೆಗೆ ಇಷ್ಟೊಂದೆಲ್ಲ ಡೀಪ್ ಆಗಿ ಹೋಗಲ್ಲ. But if you want to score out of out, you should take no chance. You should try to understand every concept. Okay. Go to the next one. ಸರ್ಕ್ಯುಲರ್ ಲೂಪ್. ಏನಿದು ಸರ್ಕ್ಯುಲರ್ ಲೂಪ್? ನೋಡಿ, ಇಲ್ಲಿದೆ ಒಂದು ವೈರ್ನ ಚೆನ್ನಾಗಿ ಹಿಂಗೆ ಬೆಂಡ್ ಮಾಡಿಬಿಟ್ಟು ಇದಾಕ್ಬಿಟ್ರೆ, ಏನಾಕ್ಬಿಟ್ರೆ ಅದರಲ್ಲಿ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಇದು ಐರನ್ ಫಿಲ್ಲಿಂಗ್ಸ್ ಹಾಕ್ಬಿಟ್ರೆ, ಇಟ್ ವಿಲ್ ಟೇಕ್ ದಿಸ್ ಶೇಪ್. ಇಟ್ ವಿಲ್ ಟೇಕ್ ದಿಸ್ ಶೇಪ್. ಓಕೆ, see the board diagram. Now they will ask one question. Remember, this question is not asked, they might ask. ಇದೆಲ್ಲ ಟೆಕ್ಸ್ಟ್ ಬುಕ್ ಅಲ್ಲಿ ಇದೆ, ಯಾವತ್ತು ಕೇಳ್ದಿರೋದನ್ನ ಕೇಳ್ಬೋದು. ದಟ್ ಇಸ್ ವಾಟ್ ಇಸ್ ಏರ್ ಬೋರ್ಡ್ ಎಕ್ಸಾಮ್. ಓಕೆ, so now what you can observe, if you see this, what all things you can observe? Very simple. You can observe few things. Firstly you can observe the magnetic field lines are curved. See, it is curved here. But as it goes to the center, curve illa, straight ಆಗ್ಬಿಡ್ತಾ ಇದೆ. Center ಹೋಗ್ತಾ straight ಆಗ್ತಾ ಇದೆ. Okay, so now this you observed. Okay, so now we'll see some of the important points. Firstly, near the wires, I told you, near the wires, they are closed loop, concentric circles. As you move away from the wire, toward the center, the circle becomes bigger, and it is become less curved and becomes straight line. At the center, it becomes straight line. So what will happen here? Remember, here ಏನಾಗುತ್ತೆ ಗೊತ್ತಾ, ಇಲ್ಲಿ 2 poles ಇರಬೇಕು. Wherever there is magnet or magnetic field, you want 2 poles, no, north and south pole. ಇಲ್ಲಿ ಯಾವುದು pole, north and south pole? Straight current carrying conductor, you can find out which is north and south. Right hand thumb rule. Okay, right hand thumb rule find ಮಾಡ್ಬೋದು ಯಾವುದು ನಾರ್ತ್ ಸೌತ್ ಅಂತ. ಆದ್ರೆ ಇದೆಲ್ಲ ಹೆಂಗ್ ಫೈಂಡ್ ಮಾಡೋದು ಯಾವುದು ನಾರ್ತ್ ಸೌತ್ ಅಂತ? 2 ಫೇಸ್ ಇರುತ್ತೆ, ಒಂದು ಸೌತ್ ಪೋಲ್ ಆಗುತ್ತೆ, ಒಂದು ಸೌತ್ ಪೋಲ್ ಆಗುತ್ತೆ, ಇನ್ನೊಂದು ನಾರ್ತ್ ಪೋಲ್ ಆಗುತ್ತೆ. ಹೆಂಗಾಗುತ್ತೆ? ಮತ್ತೆ ವಾಪಸ್ ಡಯಾಗ್ರಾಮ್ ಬರೋಣ. ಯು ಕ್ಯಾನ್ ಸಿ ನಾರ್ತ್ ಅಂಡ್ ಸೌತ್. If the current flows, see, like ಬರ್ದೀನಿ ನಾನು, if the current flows clockwise, that phase is the south pole phase. If the current flows anti-clockwise, that phase is north pole. It become like a coin. ಇದೆಲ್ಲ ಕಾಯಿನ್ ತರ ಆಗ್ಬಿಡುತ್ತೆ. ಇಲ್ಲಿಂದ ನೋಡಿದ್ರೆ ಆಯ್ತಾ, ಇಲ್ಲಿಂದ ನೋಡಿದ್ರೆ ಕರೆಂಟ್ ಕ್ಲಾಕ್ ವೈಸ್ ಹೋಗ್ತಾ ಇದೆ, ಇದು ಸೌತ್ ಪೋಲ್. ಈ ಕಡೆ ಏನಿರ್ತಾವಾಗ ನಾರ್ತ್ ಪೋಲ್. Okay, this is the speciality of circular loop. Okay, this you have to remember. Next, solenoid. See the difference? Solenoid and bar magnet. Just see the field lines. Any there is, you can you see any change? No change. The properties of bar magnet, the properties of field lines around bar magnet is same as solenoid. Same. Example ಕೇಳಿದ್ರೆ ಅಕಸ್ಮಾತ್, write the properties of solenoid. Don't get confused. Write the properties of magnetic field lines around a solenoid. The same. Okay. These are the two diagrams. Now solenoid, again very important. What all things you should know about solenoid? Firstly, the definition. What is a solenoid? Spring. What spring? Copper wire spring. Circular shape spring. Number of wound. Okay, that is your solenoid. Then inside solenoid, ನೀವೇಳಿ, inside bar magnet or inside solenoid, what is the property of field lines? Straight. Uniform, equal. Uniform, straight, inside. Okay. Next. See, the field lines are parallel straight lines. They are uniform. And this is very important point. Fourth point. Inside solenoid, outside it is going from north to south only. Outside it is going from north to south only. But inside what? Inside from south to north. Remember this point. Inside the solenoid, outside it is north to south only. But inside the solenoid, it is always from south pole to north pole they go. Next. This question it was asked recently. Using solenoid, how do you make electromagnet? Or how do you increase the strength of a solenoid? How? Sorry, question barana. How to make electromagnet? It is very simple. Take a soft iron, place inside the solenoid, pass an electricity. What happens? It becomes a strong, it becomes a magnetized. And that is called as temporary magnet. It works only when electricity is passing. Okay. So that is your how to make electromagnet. Next, how to increase the strength of this electromagnet. This you already learned. How? Increase the current, increase the number of turns, increase the current flowing to the wire, increase the number of turns. So these are the points you should remember with respect to solenoid. Now coming to next one. The very important questions regarding solenoid. This is solenoid. See this. ಯಾವುದು ಸೌತ್ ಪೋಲ್ ಯಾವುದು ನಾರ್ತ್ ಪೋಲ್ ಹೆಂಗ್ ಕಂಡುಹಿಡಿಯೋದು ಸರ್? ಆಯ್ತಾ? ನಾವು ಇಮ್ಯಾಜಿನ್ ಯು ಆರ್ ಸ್ಟ್ಯಾಂಡಿಂಗ್ ಇನ್ ಫ್ರಂಟ್ ಆಫ್ ದಿಸ್ ಪಾರ್ಟ್. ಎಸ್, ಇದರಾಗ್ಲೇ ಡಯಾಗ್ರಾಮ್ ಅಲ್ಲಿ ಇದೆ ಸೌತ್ ನಾರ್ತ್ ಅಂತ. ಬಿಟ್ಬಿಡಿ, ಮರ್ತ್ಬಿಡಿ ಇವಾಗ. ಆಯ್ತಾ? ಇದಿಲ್ಲ ಅನ್ಕೊಳ್ಳಿ. ಈ ಕಡೆ ಸೈಡ್ ನಿಂತ್ಕೊಳ್ಳಿ. ಈ ಕಡೆ ಸೈಡ್ ನಿಂತ್ಕೊಂಡು ನೋಡಿ. ಈ ಕಡೆ ಅಂದ್ರೆ ಇಲ್ಲಿದೆಯಲ್ಲ, ಒಂಥರ ಈ ತರ ಇದೆ ಅನ್ಕೊಳ್ಳಿ. ನೋಡಿ, ಇಲ್ಲಿದೆ. ಇಲ್ಲಿ ನಿಂತ್ಕೊಂಡು ನೋಡಿದೆ. ಇಲ್ಲಿ ನಿಂತ್ಕೊಂಡು ನೋಡ್ರೆ ಕರೆಂಟ್ ಹೆಂಗ್ ಹೋಗುತ್ತೆ ನೋಡಿ. ಕರೆಂಟ್ ಹಿಂಗ್ ಹೋಗುತ್ತೆ, ಕೆಳಗಡೆಯಿಂದ ಮೇಲೋಗುತ್ತೆ, ಕೆಳಗಡೆಯಿಂದ ಮೇಲೋಗುತ್ತೆ, ಹೋಗಿ ವಾಪಸ್ ಇಲ್ಲಿ ಬರುತ್ತೆ. ಆಯ್ತಾ? ಸೌತ್ ಪೋಲ್ ನಾರ್ತ್ ಪೋಲ್ ಇಲ್ವನ ಇವಾಗಷ್ಟೇ ಹೇಳಿದೆ ನಿಮ್ಗೆ. ಆಯ್ತಾ? ಇವಾಗ ಈ ಸೋಲನಾಯ್ಡ್ ನ ಕಟ್ ಮಾಡಿಬಿಟ್ರೆ, ಯಾವುದೋ ಒಂದು ಪಾಯಿಂಟ್ ಕಟ್ ಮಾಡಿಬಿಟ್ರೆ, ಇಟ್ ಬಿಕಮ್ ಸರ್ಕ್ಯುಲರ್ ಕಾಯಿಲ್. I told you in circular coil there will also be south pole and one face will be north pole. One south, one north. Then how to find which is south and north? Very simple. Okay. There are concepts. If you cannot understand the concept, questions I will come at the end. Okay. So this beginning, when the current enters, that is south pole. Where current leaves, it is the north pole. Okay. So here how to find this? You can use your right hand thumb rule and find it. Okay. So anyhow, so wherever current enters, that will be a north pole. Wherever current leaves will be your north pole. Next, this question which was asked, first question, PQR. PQR, what are the, I can ask different questions based on this diagram. I can ask, what is the magnetic field at P and Q? Are they same or different or greater? Obviously they'll be same. I told you, uniform, straight, parallel. Okay. At R, now if I ask, if C also is 1 point, okay, if C is also 1 point, R is also 1 point, and P and Q is a point, where is the magnetic field stronger? Strong illi. P and Q it is stronger. Next ಯಾವುದು? C. Next ಯಾವುದು? R. R ಆಚೆ ಇದೆ ಪಾಯಿಂಟ್. ಸೊ ರ್ಯಾಂಕಿಂಗ್ ಕೊಟ್ರೆ ಯಾರು ಬೆಸ್ಟ್ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಇದೆ, ಯಾವ ಜಾಗದಲ್ಲಿ ಬೆಸ್ಟ್ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಇದೆ, ಫಸ್ಟ್ ಪ್ಲೇಸ್ ಯಾರಿಗೆ ಬರುತ್ತೆ? First place is for P and Q, second place is for C, third place is for R. Okay. So obviously the magnetic field will be strong at the center. As you go far and far, the magnetic field reduces. Okay. Next. One second. Yeah. This question, option, fourth one. Observe the below figure. When the switch is closed, does B end of solenoid attract the north end of the bar magnet? B end will it attract? I just told. Now direction of current is not given. Be very careful. Observe properly. Current will come It will enter A and leave B. Entering point, South Pole. Coming out point, North Pole. North Pole, North Pole. Will it attract or repel? It will repel off. Okay, if at all they change the direction of current tomorrow in exam, if they change the direction of current, what you will do? If they change the current from ಇವಾಗ ಉಲ್ಟಾ ಆಗ್ಬಿಡುತ್ತೆ, ಹಿಂಗ್ ಬರುತ್ತೆ ಅನ್ಕೊಳ್ಳಿ, ಕರೆಂಟ್ ಬಿ ಇಂದ ಬರುತ್ತೆ, ಅವಾಗ ಬಿ ಪಾಯಿಂಟ್ ಏನಾಗುತ್ತೆ, ಸೌತ್ ಆಗುತ್ತೆ, ಎ ಪಾಯಿಂಟ್ ಏನಾಗುತ್ತೆ, ನಾರ್ತ್ ಆಗುತ್ತೆ. ಅವಾಗ ಏನಾಗುತ್ತೆ, ಇದು ಅಟ್ರಾಕ್ಟ್ ಆಗುತ್ತೆ. ಬಿ ಪಾಯಿಂಟ್ ಅಲ್ಲಿ ಸೌತ್ ಇದೆ, ಇದ್ರಲ್ಲಿ ನಾರ್ತ್ ಇದೆ, ಅಟ್ರಾಕ್ಟ್ ಆಗ್ಬಿಡುತ್ತೆ. ಟು ರಿಮೆಂಬರ್, ವೇರ್ ಅವರ್ ಕರೆಂಟ್ ಎಂಟರ್ಸ್, ಸೌತ್ ಪೋಲ್, ಲೀವ್ಸ್ ನಾರ್ತ್ ಪೋಲ್. Next, very important. What is this diagram? What is all this fuss about? This is a very important experiment. If this experiment was not done in the history of electricity or history of science, we would have not got fan, we would have not got this laptop, we would have still been in the darkness. This is a very basic experiment, very important experiment. Okay, that is you need to understand. ಅದಕ್ಕೆ ಕೇಳ್ತಾನೆ ಇರ್ತಾರೆ ಎಕ್ಸಾಮ್ ಅಲ್ಲಿ, what is this? Just see the stand. Everybody know what is stand? Just see one wire, AB. AB is an aluminum rod. It's an aluminum rod with a good conductor, and it will not, you know, no, aluminum and copper will not attract to magnet. Correct? What will attract to magnet? Iron will attract. Nickel and cobalt will attract. Copper and aluminum will never attract the magnet. But we are using an AB aluminum and connecting it to what? Electricity. Now I told you Oersted did an experiment. He took a conductor, he passed electricity. What will happen? Around this conductor there will be a magnetic field. Now if at all I get a compass, what will happen to the compass? I told you that time. The compass will start deflecting. Why? Magnetic field, magnet deflecting. Now what if I get, instead of compass, get a horseshoe magnet, strong horseshoe magnet? ಏನಾಗುತ್ತೆ, ಇದು ಎ ಬಿ ರಾಡು ಆಯ್ತಾ, ಅದೇ ಮೂವ್ ಆಗಕ್ಕೆ ಶುರು ಆಗ್ಬಿಡುತ್ತೆ. ದೇರ್ ವಿಲ್ ಬಿ ಫೋರ್ಸ್ ಎಕ್ಸ್ಪೀರಿಯನ್ಸ್. ಯಾರು ಎಕ್ಸ್ಪೀರಿಯನ್ಸ್ ಮಾಡ್ತಾರೆ ಫೋರ್ಸ್? ಸಿ, ಫೋರ್ಸ್ ಆನ್ ಕರೆಂಟ್ ಕ್ಯಾರಿಂಗ್ ಕಂಡಕ್ಟರ್. ಪದ ಬಿಟ್ಟೋಗಿದೆ ಇಲ್ಲಿ. ಫೋರ್ಸ್ ಆನ್ ಕರೆಂಟ್ ಕ್ಯಾರಿಂಗ್ ಕಂಡಕ್ಟರ್ ವೇರ್ in a magnetic field. How do you get the magnetic field? By the horseshoe magnet. How did now there are three things here. ಗೊತ್ತಿರಲಿ, ಮೂರು ಥಿಂಗ್ಸ್ ಇದೆ ಇಲ್ಲಿ. ಒಂದೇನು, ಒಂದು ಕರೆಂಟ್ ಇದೆ. ಕರೆಂಟ್ ಇಲ್ಲ ಅಂದ್ರೆ there will be no magnetic field around AB. That is first point. Second point ಏನು, there is magnetic field lines. By whom? By the horseshoe magnet. Third one, what is there? Because of this magnetic field line and current, there is force. Now three things: force, current, magnetic field lines. Remember this. We want to understand this. Okay, what is this experiment? Very simple. I told you it will move. This AB rod will move. It will come, it will go away, it will come back, front, right, left, it will go. So this experiment they will ask. So this one, these are the everything you have to understand this. They were asked in model paper, they were asked in preparatory also. Explain the experiment to show the current carrying conductor when kept in a magnetic field experience a mechanical force. So ಅದನ್ನೇನು ಎಕ್ಸ್ಪ್ಲೇನ್ ಮಾಡಿದೆ, ಓನ್ ವರ್ಡ್ಸ್ ಅಲ್ಲಿ ಬರೆದ್ಬಿಟ್ರೆ ಆಯ್ತು. ನೆಕ್ಸ್ಟ್, this some very important points regarding this, some very important points. Firstly, the current carrying conductor will experience a physical force when placed in magnetic field. This you understood. Second one, very important, the direction of force is always perpendicular to both the direction of current and magnetic field. That is why, very simple, anything they will ask, Fleming's left hand rule, you will tell the statement now. All take the right hand, take the left hand, make sure that all the fingers are mutually perpendicular, 90 degree, 90 degree, 90 degree. Okay, they're all perpendicular. Only when they're perpendicular, the force is highest. Keltare, the force is highest when the direction between the current and magnetic field is 90 degree. When current, which is current, father, mother, child. Okay, so this is current, this is magnetic field. When magnetic field and the current are exactly 90 degree, the force will be maximum, more force, 90 degree. Remember this. When they're parallel, ಇದು ಪ್ಯಾರಲ್ ಆಗಿದ್ಬಿಟ್ರೆ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಪ್ಯಾರಲ್, ಇದು ಪ್ಯಾರಲ್, ಇದು ವರ್ಕೇ ಆಗಲ್ಲ, ಫೋರ್ಸೇ ಬರಲ್ಲ, ಝೀರೋ ಫೋರ್ಸ್. ರಿಮೆಂಬರ್, when the force is highest, 90 degree, between whom? Between current and magnetic field. When the force is zero, when they are placed together. Okay. Next, lastly, why do you use Fleming's left hand rule? ಯಾಕೆ ಬೇಕಪ್ಪ Fleming's left hand rule? Right hand thumb rule ಯಾಕೆ ಬೇಕು? I told you we want to find the direction of magnetic field lines. Why do you want left hand rule? To find the direction of force. Force ಎಲ್ಲಿ ಬರುತ್ತೆ ಅಂತ ಕಂಡುಹಿಡಿಯಕ್ಕೆ. So these things you should remember. Next, Fleming's left hand rule, everybody knows, father, mother, child. I told you already. This thumb stands for force. This stands for magnetic field lines, mother. Magnetic field lines. C stands for child, current. Okay, father, mother, child. Some also remember this as motion. This has field lines. Then it becomes mother, father, child. But best is this. This is very easy. Father, mother, child. Okay. So then you know to expand it and write. Why we use it? I already told you. To find the direction of force of the conductor. This question. ಅಯ್ಯೋ ವಾಟ್ ಇಸ್ ದಿಸ್ ಕ್ವಶನ್? ದಿಸ್ ಇಸ್ ಅಗೇನ್ ಟು ಯೂಸ್ ದ ಫ್ಲೆಮಿಂಗ್ಸ್ ಲೆಫ್ಟ್ ಹ್ಯಾಂಡ್ ರೂಲ್. ಬಯಟ್ ಹೊಡೆದ್ಬಿಡೋದು, ಯಾರು ಬೇಕಾದ್ರೆ ಬಯಟ್ ಹೊಡಿತಾರೆ. ಯೂಸ್ ಮಾಡಕ್ಕೆ ಅದಕ್ಕೆ ತಲೆ ಬೇಕು. ರೈಟ್ ಹ್ಯಾಂಡ್ ತಮ್ ರೂಲ್, ಯಾರು ಬೇಕಾದ್ರೆ ಬಯಟ್ ಹೊಡಿತಾರೆ. ಯೂಸ್ ಮಾಡಕ್ಕೆ ತಲೆ ಬೇಕು, ಅರ್ಥ ಆಗಿರ್ಬೇಕು ಕಾನ್ಸೆಪ್ಟ್. ಹಂಗೆ ಇಲ್ಲಿ ಫ್ಲೆಮಿಂಗ್ಸ್ ಲೆಫ್ಟ್ ಹ್ಯಾಂಡ್ ರೂಲ್, ಬಯಟ್ ಹೊಡಿತೀಯಾ, ನಾವು ಬಯಟ್ ಹೊಡಿಯೋರಿಗೆಲ್ಲ ಬೆಲೆ ಕೊಡಲ್ಲ ಅಂತ ಈ ತರ ಕ್ವಶನ್ಸ್ ಕ್ರಿಯೇಟ್ ಮಾಡ್ತೀವಿ. ಓಕೆ, ಸೊ ನಾವು ಟೂ ಕ್ವಶನ್ಸ್, ದಿಸ್ ಟೂ ಕ್ವಶನ್ಸ್. ನಾವು ಸಿ ದಿಸ್ ಕ್ವಶನ್, ದೇ ಆರ್ ಆಸ್ಕಿಂಗ್. ನಾನು ಬರ್ದ್ಬಿಟ್ಟಿದ್ದೀನಿ ಆನ್ಸರ್, ಬಿಡಿಯೋದು ಅದಿಲ್ಲ ಅನ್ಕೊಳ್ಳಿ. ಮ್ಯಾಗ್ನೆಟಿಕ್ ಪೋಲ್ ಎ, ಮ್ಯಾಗ್ನೆಟಿಕ್ ಪೋಲ್ ಬಿ. ವಾಟ್ ಈಸ್ ದ ಪೋಲ್? ಎ ಅಲ್ಲಿ ಯಾವ ಪೋಲ್ ಇದೆ, ಬಿ ಅಲ್ಲಿ ಯಾವ ಪೋಲ್ ಇದೆ ಅಂತ ಕೇಳ್ತಿದ್ದಾರೆ. ಅಂಡ್ ಇಟ್ ಸೀಮ್ಸ್ ದೇರ್ ಇಸ್ ಎ ಬೀಮ್ ಆಫ್ ಎಲೆಕ್ಟ್ರಾನ್ಸ್. ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಆರ್ ಗೋಯಿಂಗ್ ಬಿಟ್ವೀನ್ ದಿಸ್ ಮ್ಯಾಗ್ನೆಟ್ಸ್. They're going between these magnets. Okay, what happens when they go between these magnets? They are told in the question, a given diagram represents the experiment conducted to observe the deviation of beam of electrons when the beam enters the magnetic field perpendicularly if the beam deviates in the direction out of the surface of the paper. ಅಂದ್ರೆ ಹಿಂಗ್ ಬಂದ್ಬಿಡುತ್ತೆ, ನನ್ನ ಹತ್ರ ಬರ್ತಾ ಇದೆ ಬೀಮ್, ಹಿಂಗೆ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಹಿಂಗ್ ಬಿಡ್ತಾ ಇದ್ದೀನಿ, ಎಲ್ಲಿ ಬಿಡ್ತಾ ಇದ್ದೀನಿ. ಐ ಆಮ್ ಲೀವಿಂಗ್ ಇಟ್ ಇನ್ಸೈಡ್ ಬಿಟ್ವೀನ್ ದಿಸ್ ಮ್ಯಾಗ್ನೆಟ್ಸ್. ಇಮ್ಯಾಜಿನ್ ದೇರ್ ಆರ್ ಟೂ ಮ್ಯಾಗ್ನೆಟ್ಸ್ ಅಬೌವ್ ಅಂಡ್ ಬಿಲೋ, magnet A, magnet B. Now beam of electron is going, what will happen? It will go inside and come towards me. ನನ್ನ ಮುಖಕ್ಕೆ ಹೊಡಿತಾ ಇದೆ. It is coming outside the surface of the paper. ನನ್ನ ಮುಖಕ್ಕೆ ಹೊಡಿತಾ ಇದೆ. That means there is a force. Somebody is putting force. And electrons is nothing but current. But there is a twist here. Electricity, electric current and electrons. Correct. Electricity ಯಾರಿಂದ? ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಇಂದಾನೆ. ಬಟ್ always remember this, electricity chapter, interconnect. Electricity chapter, first page only we are explaining that. Electrons ಕಂಡಿಡಿಯಕ್ಕಿಂತ ಮುಂಚೆನೆ ನಾವು ಎಲೆಕ್ಟ್ರಿಸಿಟಿನ ಕಂಡಿಡಿದು ಬಿಟ್ಟಿದ್ವಿ. ಏನ್ ಅನ್ಕೊಂಡಿದ್ವಿ? ಕರೆಂಟ್ ಯಾರೋ ಪಾಸಿಟಿವ್ ಇಂದ ನೆಗೆಟಿವ್ ಕಡೆ ಹೋಗ್ತಾ ಇದ್ದಾರೆ ಅಂತ ಅನ್ಕೊಂಡ್ಬಿಟ್ಟಿದ್ವಿ. ಬಟ್ ಆಮೇಲೆ ಏನ್ ಗೊತ್ತು, ರಿಯಾಲಿಟಿ ಏನ್ ಗೊತ್ತಾಯ್ತು? ವಿ ಗಾಟ್ ದ ರಿಯಾಲಿಟಿ. Science later on got to know that actually it is electrons moving from negative to positive. So always remember, current direction is opposite to electron direction. Current direction is opposite to electron direction. ಇವಾಗ ಫ್ಲೆಮಿಂಗ್ಸ್ ಲೆಫ್ಟ್ ಹ್ಯಾಂಡ್ ರೂಲ್ ಏನ್ರ ಬಗ್ಗೆ ಮಾತಾಡ್ತಿದೆ? ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಬಗ್ಗೆ ಮಾತಾಡ್ತಿದ್ಯಾ? ನೋ, ಇಟ್ ಇಸ್ ಟಾಕಿಂಗ್ ಅಬೌಟ್ current. It is talking about current. This finger talking about current. Now for this diagram, what I should do now? Okay, see my fingers properly. Okay, I should find out north pole, which is north pole, which is south pole. What I have the force direction, I have the current direction. Current ಹೆಂಗಿದೆ? ಇದು ಕರೆಂಟಾ? ಈ ಕೈ ತಾನೆ ಕರೆಂಟ್. ಕರೆಂಟ್ ಹೆಂಗ್ ಹೋಗ್ತಿದೆ? ಹಿಂಗ್ ಹೋಗ್ತಿದೆ. ಆಯ್ತಾ? ಆಗ್ತದೆ, ಹಿಂಗ್ ಹೋಗ್ತಾ ಇದೆ. ಇದೇನು? ಫೋರ್ಸು. ಫೋರ್ಸ್ ಹಿಂಗಿದ್ಯಾ? ಫೋರ್ಸು ನೋಡಿ, ಕರೆಕ್ಟ್ ಆಗಿ ನೋಡಿ, ಈ ತರ ನೋಡಿ, ಕೈ ಕರೆಕ್ಟ್ ಆಗಿ ನೋಡಿ. ಫೋರ್ಸ್ ನನ್ನ ಕಡೆ ಇದೆ, ತಮ್ ನೋಡಿ, ನನ್ನ ಕಡೆ ಇದೆ ತಮ್, ನನ್ನ ಕಡೆ ಫೋರ್ಸ್ ಬರ್ತಿದೆ. ಇದೇನಿದು? ಕರೆಂಟ್. ಸಿ ದಿಸ್ ಇಂಡೆಕ್ಸ್ ಫಿಂಗರ್, ಇಟ್ ಇಸ್ ಗೋಯಿಂಗ್ ಡೌನ್ವರ್ಡ್ಸ್. This is going beam of electrons, opposite is current. See, my middle finger is showing what direction? It is showing current direction. Father, mother, child, current direction. Correct. Then what is this showing? This is showing, now what is thumb showing? Force coming towards me, electrons. Then what is this showing? Magnetic field lines. It is coming towards this, which is north and which is south. Start agodu north to end agodu south, north, south. So A point ಏನು? North pole. B point ಏನು? South pole. Which principle we use? Fleming's left hand rule. Now we'll understand a little better more with this question. This question preparatory ಮೊನ್ನೆ ಕೇಳಿದ್ರು. ಓಕೆ, ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಇದೆ, ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಹೋಗ್ತಾ ಇದೆ. ವೇರ್ ವಿಲ್ ಬಿ ದ ಡೈರೆಕ್ಷನ್ ಆಫ್ ಎಲೆಕ್ಟ್ರಾನ್ಸ್? Direction of electrons. Now we will see the left hand rule. Okay, current, this is current. Now current is not going upward, it is going downward, opposite to electrons. Magnetic field, which is magnetic field? This is magnetic field. How? ಹಿಂಗ್ ಮಾಡಬೇಕು, ಆಯ್ತಾ? ಕರೆಂಟ್ ನೋಡಿ, ಇವಾಗ ಕರೆಕ್ಟಾ? ಒಂದ್ ನಿಮಿಷ, ನಾನು ಲೆಫ್ಟ್ ಹ್ಯಾಂಡ್ ಯೂಸ್ ಮಾಡ್ತೀನಿ, ಲೆಫ್ಟ್ ಹ್ಯಾಂಡ್ ಯೂಸ್ ಮಾಡ್ತೀನಿ. ಓಕೆ, ನೀವು ಮಿಸ್ಟೇಕ್ ಮಾಡಬೇಡಿ. ರೈಟ್ ಹ್ಯಾಂಡ್ ಯೂಸ್ ಮಾಡ್ಕೊಂಡು ಮಾಡಿದ್ರೆ ತಪ್ಪಾಗೋಗ್ಬಿಡುತ್ತೆ. ಲೆಫ್ಟ್ ಹ್ಯಾಂಡ್ ಯೂಸ್ ಮಾಡ್ಕೊಂಡೇ ಮಾಡಬೇಕು. ಸೊ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಎಲ್ಲಿ, ಯಾವ ಕಡೆ ಹೋಗ್ತಿದೆ ಇವಾಗ? ಕರೆಂಟ್ ಎಲ್ಲಿ? ಕೆಳಗಡೆ ಹೋಗ್ತಾ ಇದೆ. ಆಯ್ತಾ? ಸೊ ಕರೆಂಟ್ ಕೆಳಗಡೆ. ಯಾವ್ದು ಕರೆಂಟ್? ಇದು ಕರೆಂಟಾ? ಕರೆಂಟ್ ಕೆಳಗಡೆ ಹೋಗ್ತಾ ಇದೆ. ಕರೆಕ್ಟಾ? ನೆಕ್ಸ್ಟ್ ಏನು? ದೇ ಆರ್ ಆಸ್ಕಿಂಗ್ ಫೋರ್ಸ್. ಫೋರ್ಸ್ ತಮ್ ಡೈರೆಕ್ಟ್, ಅದು ನೋಡೋಣ ಅದು. ಬಟ್ ಇನ್ಯಾವುದು? ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಲೈನ್ಸ್ ಹೆಂಗ್ ಹೋಗ್ತಾ ಇದೆ? ಈ ಕಡೆ ಹೋಗ್ತಾ ಇದೆ. ನೋಡಿ, ಇದು ಕರೆಕ್ಟಾ? ಡೈರೆಕ್ಷನ್ ನೋಡಿ, ಇದು ಕರೆಕ್ಟ್. ನೌ ಇಫ್ ಯು ಸಿ, ವೇರ್ ಆರ್ ದ ಮೈ ಥಂಬ್ ಇಂಡಿಕೇಟಿಂಗ್ ಮೈ ಥಂಬ್ ಇಸ್ ಗೋಯಿಂಗ್ ಇನ್ಸೈಡ್ ದ ಪೇಪರ್. ನಿಮ್ಮ ಹತ್ರ ಬರ್ತಾ ಇದೆ ನೋಡಿ, ಇಟ್ ಇಸ್ ಗೋಯಿಂಗ್ ಇನ್ಸೈಡ್ ದ ಕ್ಯಾಮ್ರಾ. ಇಟ್ ಇಸ್ ಗೋಯಿಂಗ್ ಇನ್ಸೈಡ್ ದ ಕ್ಯಾಮ್ರಾ. ಓಕೆ, ಸೊ ದಿಸ್ ಇಸ್ ಫ್ಲೆಮಿಂಗ್ಸ್ ಲೆಫ್ಟ್ ಹ್ಯಾಂಡ್ ರೂಲ್. ಅಕಸ್ಮಾತ್ ಉಲ್ಟಾ ಕೇಳಿದ್ರೆ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಲೈನ್ಸ್ ಈ ಕಡೆ ಇತ್ತು ಅನ್ಕೊಳ್ಳಿ, ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಹಂಗಿದೆ, ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಲೈನ್ಸ್ ಈ ಕಡೆ ಹೋಗ್ತದೆ. ಅವಾಗ ಏನ್ ಮಾಡ್ಬೇಕು ನಾನು? ಆಯ್ತಾ, ಇದು ಡಯಾಗ್ರಾಮ್, ಇದು ಕರೆಂಟ್ ಫ್ಲೋಯಿಂಗ್ ಆಪೋಸಿಟ್ ಟು ಎಲೆಕ್ಟ್ರಾನ್ಸ್, ಇದು ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಲೈನ್ಸ್. ತಮ್ ನೋಡಿ ನನ್ನ ಕಡೆ ಬರ್ತಿದೆ, ಫೋರ್ಸ್ ನನ್ನ ಕಡೆ, ಔಟ್ಸೈಡ್ ದ ಪೇಪರ್. ಓನ್ಲಿ ಟೂ ಆಪ್ಷನ್, ಇನ್ಸೈಡ್ ಆರ್ ಔಟ್ಸೈಡ್. ಎಕ್ಸಾಮ್ ಅಲ್ಲಿ ಯಾರಾದ್ರೂ ನಿಮ್ಗೆ ಡೈರೆಕ್ಷನ್ ಆಫ್ ಫೋರ್ಸ್ ಕೇಳಿದ್ರೆ ಎರಡೇ ಆಪ್ಷನ್ ಇರಕ್ಕೆ ಸಾಧ್ಯ, ಇನ್ಸೈಡ್ ಇಲ್ಲ ಔಟ್ಸೈಡ್. ಇನ್ಸೈಡ್ ಆರ್ ಔಟ್ಸೈಡ್. ಓಕೆ, ಮೇಕ್ ಶ್ಯೂರ್ ಯು ಆರ್ ಆಲ್ವೇಸ್ ಯೂಸಿಂಗ್ ದ ಲೆಫ್ಟ್ ಹ್ಯಾಂಡ್. ರೈಟ್ ಹ್ಯಾಂಡ್ ಯೂಸ್ ಮಾಡ್ಕೊಂಡು ಮಾಡಿದ್ರೆ ಮುಗೀತು, ನಿಮ್ಗೆ ತಪ್ಪಾಗಿ ಹೋಗ್ಬಿಡುತ್ತೆ. ಓಕೆ, so this one properly you understand. You want still more, we will see at the end of this session. Okay, next, lastly, I told you 220 volts potential difference between live wire and neutral wire. Live wire red color positive, neutral wire black, earth wire green. What is fuse? I already told you. So these things you have to remember. Light chapter, beg over light chapter. 1 marks, 3 marks, 4 marks. 3 marks 100% ray diagram. ನಿಮ್ಮೆಲ್ರಿಗೂ ಬಂದೇ ಬರುತ್ತೆ ಅನ್ಕೊಂಡಿದ್ದೀನಿ ray diagram. Ray diagram is very important. Next, 1 marks, obviously some mirrors, some definitions they might ask, some high order thinking questions they might ask. 4 marks ಇಲ್ಲವರೆಗೂ ಒಂದನ್ನು ಕೇಳೇ ಇಲ್ಲ, ನ್ಯೂಮರಿಕಲ್ಸ್ ಕೇಳಿಲ್ಲ. ಬಟ್ ಇದರಲ್ಲಿದೆ, ಯಾವ್ದ್ರಲ್ಲಿ? ಮಾಡೆಲ್ ಪೇಪರ್ ಅಲ್ಲಿ ಇದೆ, ಪ್ರಿಪೇಟರಿ ಕೇಳಿಲ್ಲ. ಕೇಳೋ ಚಾನ್ಸಸ್ ಇದೆ, ಅದನ್ನು ಗ್ಯಾಪ್ ಇಟ್ಕೊಳ್ಳಿ. ನ್ಯೂಮರಿಕಲ್ಸ್ ಪ್ರಾಕ್ಟೀಸ್ ಮಾಡಿ ಬಿಟ್ಬಿಡ್ಬೇಡಿ. ಐ ಟೋಲ್ಡ್ ಯು, ಒಂದೊಂದೇ ಯಾವ್ದೋ ಕೇಳಿಲ್ಲ, ಮಾಡೆಲ್ ಪೇಪರ್ ಒಂದೇ ಕ್ವಶನ್ ಇದೆ, ಎಲ್ಲೂ ಕೇಳಿಲ್ಲ, ಅದನ್ನ ಬಿಟ್ಬಿಡೋಣ ಏನಾಗುತ್ತೆ ಅಂತ ರಿಸ್ಕ್ ತಗೊಂಡ್ಬಿಡಿ, ಎಲ್ಲಾನು ಓದಿರ್ಬೇಕು. Okay, 4 marks, loss of reflection, refraction, and there are some more concepts, glass slab experiment, everything we will see. This is the outline of the chapter. Firstly, plane mirror, dina belige nodtivi. Firstly, understand, like what you are seeing my face. Imagine like the plane mirror. Okay, you are seeing my face in your mobile. It is a virtual image. Am I real? Real ಆಗಿ ನಿಮ್ಮ ಮನೆಗೆ ಬಂದ್ಬಿಟ್ಟಿದೀನಾ? ಬಂದಿಲ್ಲ, ವರ್ಚುವಲ್ ಕಾಣಿಸ್ತಾ ಇದ್ದೀನಿ. ಇಲ್ಲಿ ಮೊಬೈಲ್ ಒಳಗಡೆ ಇರೋ ತರ ಕಾಣಿಸ್ತಾ ಇದ್ದೀನಿ. ಸೊ ಐ ಆಮ್ ಎ ವರ್ಚುವಲ್ ಇಮೇಜ್. ಆಮ್ ಐ ಸೇಮ್? ಮೈ ಸೈಜ್ ಇಸ್ ಸೇಮ್ ಆರ್ ಡಿಫರೆಂಟ್? ನಾನು ಚಿಕ್ಕದಾಗ ದೊಡ್ಡದಾಗ ಕಾಣಿಸ್ತೀನಿ? ನೋ, ಮೈ ಸೈಜ್ ಇಸ್ ಸೇಮ್. ಮೈ ಸೈಜ್ ಇಸ್ ಸೇಮ್ ಇನ್ ಯುವರ್ ಮೊಬೈಲ್ ಆಲ್ಸೋ. ಅಂಡ್ ದ ಡಿಸ್ಟೆನ್ಸ್ ಬಿಟ್ವೀನ್, ಓಕೆ, ಮೈ ಫೇಸ್ ಅಂಡ್ ದ ಲ್ಯಾಪ್ಟಾಪ್ ಅಂಡ್ ಯುವರ್ ಮೊಬೈಲ್ ಅಂಡ್ ಮೈ ಸೆಲ್ಫ್ ಇನ್ ದಟ್ ಇಸ್ ದ ಸೇಮ್. ದ ಡಿಸ್ಟೆನ್ಸ್ ಬಿಟ್ವೀನ್ ಆಬ್ಜೆಕ್ಟ್, ಪ್ಲೇನ್ ಮಿರರ್ ಮುಂದೆ ನಿಂತ್ಕೊಂಡ್ರೆ ನೀವು 1 ಮೀಟರ್ ದೂರದಲ್ಲಿ ನಿಂತ್ಕೊಳ್ಳಿ, ಕನ್ನಡಿ ಒಳಗಡೆ ನೀವು ಕಾಣಿಸ್ತೀರಾ? ಎಷ್ಟು 1 ಕಿಲೋಮೀಟರ್ ದೂರದಲ್ಲಿ ಕಾಣಿಸ್ತೀರಾ? 2 ಕಿಲೋಮೀಟರ್ ದೂರದಲ್ಲಿ ಕಾಣಿಸ್ತೀರಾ? ಹತ್ರ ಕಾಣಿಸ್ಬಿಡ್ತೀರಾ? ಇಲ್ಲ ಅಲ್ಲ. ಇಫ್ ದ ಡಿಸ್ಟೆನ್ಸ್ ಫ್ರಮ್ ದ ಮಿರರ್ ಅಂಡ್ ಯು ಇಸ್ 1 meter, ಮಿರರ್ ಟು ಯುವರ್ ಇಮೇಜ್ ಇಸ್ ಆಲ್ಸೋ 1 meter. ಓಕೆ, ಸೊ ದಟ್ ಇಸ್ ಯು ಇಸ್ ಈಕ್ವಲ್ ಟು ವಿ. ಏನಿದು ಸರ್? ಇಲ್ಲಿ ನ್ಯೂಮರಿಕಲ್ಸ್ ಕಾನ್ಸೆಪ್ಟ್, ಇದು ಕನೆಕ್ಟ್ ಮಾಡಬಹುದು. ಓಕೆ, that will come again. Next, always remember, plane mirror always produces what? Always an erect image, same size. It produces virtual image, erect image, same size. Magnification, what is magnification? ಬೂತ್ ಕನ್ನಡಿ, ನೀವೆಲ್ಲ ಆಟ ಆಡಿರ್ತೀರ. ಬೂತ್ ಕನ್ನಡಿಯಲ್ಲಿ ತಗೊಂಡೋದ್ರೆ ದೊಡ್ಡದಾಗುತ್ತೆ. ನಿಮ್ ಪ್ಲೇನ್ ಮಿರರ್ ನೋಡಿದ್ರೆ ನಿಮ್ ಮುಖ ದೊಡ್ಡದಾಗುತ್ತಾ, ಚಿಕ್ಕದಾಗುತ್ತಾ? ಏನೂ ಆಗಲ್ಲ, ನಿಮ್ ಮುಖ ಹೆಂಗಿರುತ್ತೆ ಹಂಗೆ ಇರುತ್ತೆ. ಸೊ ಮ್ಯಾಗ್ನಿಫಿಕೇಶನ್ ಇಸ್ ಆಲ್ವೇಸ್ +1 ಆಫ್ ಪ್ಲೇನ್ ಮಿರರ್ ಇಸ್ +1. ಲ್ಯಾಟ್ರಲ್ ಇನ್ವರ್ಷನ್, ದಟ್ ಯು ನೋ, ಆಂಬ್ಯುಲೆನ್ಸ್ ಗಾಡಿಯಲ್ಲಿ ಉಲ್ಟಾ ಬರ್ದಿರ್ತಾರೆ, ಕನ್ನಡಿಯಲ್ಲಿ ನೋಡಿದಾಗ ಸರಿಯಾಗಿ ಕಾಣಿಸ್ಲಿ ಅಂತ. ಸೊ ದೀಸ್ ಆರ್ ದ ಪ್ರಾಪರ್ಟೀಸ್. ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್ ದ ಪ್ರಾಪರ್ಟೀಸ್. ಇದ್ರ ಬೇಸಿಸ್ ಮೇಲೆ ತುಂಬಾ ಕ್ವಶನ್ಸ್ ಕೇಳ್ಬೋದು. ಪ್ಲೇನ್ ಮಿರರ್ ಅಂಡರ್ಸ್ಟುಡ್ ನೋ, ಇಟ್ ವಿಲ್ ಆಲ್ವೇಸ್ ಪ್ರೊಡ್ಯೂಸ್ ವರ್ಚುವಲ್. ದೆನ್ ವಾಟ್ ಇಸ್ ಆಪೋಸಿಟ್ ಆಫ್ ವರ್ಚುವಲ್? ರಿಯಲ್ ಇಮೇಜ್. ವಾಟ್ ಇಸ್ ರಿಯಲ್ ಇಮೇಜ್? ನನ್ನ ಮುಖ ಕನ್ನಡಿ ಗೊಡ್ದು ಆಚೆ ಕಾಣಿಸ್ಬೇಕು, ಕಾಣಿಸುತ್ತಾ? ಆಚೆ ಎಲ್ಲ ಕಾಣಿಸಲ್ಲ, ಕನ್ನಡಿಯಲ್ಲಿ ಮಾತ್ರ ಕಾಣಿಸೋದು. ಆದ್ರೆ ಒಂದು ಮಿರರ್ ಇದೆ, ಕಾನ್ಕೇವ್ ಮಿರರ್ ಅಂತ ಸ್ಪೆಷಲ್ ಇದೆ. ಅದ್ರಲ್ಲಿ ಕ್ಯಾಂಡಲ್ ಇಟ್ರೆ ಮುಂದೆ ಕ್ಯಾಂಡಲ್ ಹೊಡೆದು ಆಚೆ ರಿಫ್ಲೆಕ್ಟ್ ಆಗಿ ಅಲ್ಲೆಲ್ಲೋ ಕಾಣಿಸ್ತಾ ಇರುತ್ತೆ ಕ್ಯಾಂಡಲ್ ಫ್ಲೇಮ್. ಅದನ್ನ ರಿಯಲ್ ಇಮೇಜ್. ರಿಯಲ್ ಇಮೇಜ್ ಮೀನ್ಸ್ ವಿ ಕ್ಯಾನ್ ಪುಟ್ ಆನ್ ದ ಸ್ಕ್ರೀನ್. ಯು ಕ್ಯಾನ್ ಸಿ ಇಟ್ ಆನ್ ಎ ಸ್ಕ್ರೀನ್. ಓಕೆ, ಸೊ ಪ್ಲೇನ್ ಮಿರರ್ ಆಲ್ವೇಸ್ ಪ್ರೊಡ್ಯೂಸಸ್ ವರ್ಚುವಲ್ ಇಮೇಜ್, ಸೇಮ್ ಸೈಜ್, ಎರೆಕ್ಟ್ ಇಮೇಜ್, ಮ್ಯಾಗ್ನಿಫಿಕೇಶನ್ 1. +1. Why +1? I am standing. Am I ulta in your screen? No, I am same only, no, straight only, no. So that is why it is +1. These are the properties of plane mirror. Let's go to loss of reflection. ನೋಡಿ, ಡಯಾಗ್ರಾಮ್ ನೋಡಿದ್ರೆ ಅರ್ಥ ಆಗೋಗ್ಬಿಡುತ್ತೆ. The incident ray and the angle of incident I is equal to R. The angle of incident ray, the angle of reflected ray are both equal. What is the second law? The incident ray, the reflected ray and the normal ray all lie in the same plane. ಇಲ್ಲಿ ನೋಡಿ, ಡಯಾಗ್ರಾಮ್ ಅಲ್ಲಿ ನೋಡಿ, ಇದೇನೋ ಒಂದು ಬಾಕ್ಸ್ ತರ ಇದೆ ಮೇಲೆ ನಿಂತ್ಕೊಂಡಿರೋ ಬಾಕ್ಸ್. ಅದು ಇಮ್ಯಾಜಿನರಿ, ಹೈಪೋಥೆಟಿಕಲ್ ಕೊಟ್ಟಿದ್ದಾರೆ ನೋಡಿ, ಹೈಪೋಥೆಟಿಕಲ್ ಪ್ಲೇನ್ ಅದಿಲ್ಲ ಅಲ್ಲಿ. ಏನ್ ಅರ್ಥ ಇದು ಅಂದ್ರೆ, ಹಿಂಗ್ ಹೊಡೆದು ರೇ, ಹಿಂಗ್ ಹೊಡೆದು ಮತ್ತೆ ವಾಪಸ್ ಹೋಗುತ್ತೆ. ಇಟ್ ವಿಲ್ ಬಿ ಇನ್ ಸೇಮ್ ಪ್ಲೇನ್. ಹಿಂಗ್ ಹೊಡೆದ್ಬಿಟ್ಟು ಹಿಂಗ್ ಕೆಳಗಡೆ ಹೋಗ್ಬಿಡಲ್ಲ. ರಾಕೆಟ್ ತರ ಹಿಂಗ್ ಹೊಡೆದ್ಬಿಟ್ಟು ಗೋಡೆಗೆ ಹೊಡೆದ್ಬಿಟ್ಟು ಹಿಂಗ್ ಕೆಳಗಡೆ ಹೋಗ್ಬಿಡಲ್ಲ, ಬೇರೆ ಡೈರೆಕ್ಷನ್ ಹೋಗಲ್ಲ. ಇಟ್ ವಿಲ್ ಹಿಟ್ ಅಂಡ್ ಗೋ ಇನ್ ದ ಸೇಮ್ ಪ್ಲೇನ್. ಇಫ್ ದಿಸ್ ಇಸ್ ಒನ್ ಪ್ಲೇನ್, ಇಟ್ ವಿಲ್ ಹಿಟ್ ಅಂಡ್ ಗೋ ಇನ್ ದ ಸೇಮ್ ಲೆವೆಲ್. ಪ್ಲೇನ್ ಅಂದ್ರೆ ಲೆವೆಲ್, ಸೇಮ್ ಲೆವೆಲ್. ಆ ಲೆವೆಲ್ ಹಿಂಗ್ ತೋರಿಸಿದಾರೆ ಅಷ್ಟೇ. ಸೊ ಲಾಸ್ ಆಫ್ ರಿಫ್ಲೆಕ್ಷನ್ ಯು ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್. What is this? Now we'll go to spherical mirrors. Consider a big football. First one, diagram A. Big football. Diagram B is also big football. But in diagram A, the football, inside the football, there is mirror. Outside, no mirror. Inside mirror, outside no mirror. Next football, outside mirror, inside nothing. Now take a knife and cut both of them. That is what is dotted lines. So what you will get? You will get spherical mirrors. That is why concave mirror and convex mirrors are called as the spherical mirrors. Spherical. Okay? They are called as the spherical mirrors. So now you see this is concave. Cave ಇದೆ. ಎಂಟ್ರಿ ಆದ ತಕ್ಷಣ ಕನ್ನಡಿಗೆ ಕೇವ್ ಇದೆ. ಇಲ್ಲಿ ಕೇವ್ ಇಲ್ಲ, ನನ್ನ ಮುಂದೆನೆ ಹೊಡೆದಂಗಿದೆ. ಕಾನ್ವೆಕ್ಸ್ ಅಲ್ಲಿ ಇಟ್ ಇಸ್ ಬಲ್ಜ್ ಔಟ್ವರ್ಡ್ಸ್, ದಿಸ್ ಇಸ್ ಬಲ್ಜ್ ಇನ್ವರ್ಡ್ಸ್. ಓಕೆ, ಸೊ ನೌ ಲೆಟ್ಸ್ ಗೋ ಟು ದ ನೆಕ್ಸ್ಟ್ ಕಾನ್ಸೆಪ್ಟ್ಸ್. ರೇ ಡಯಾಗ್ರಾಮ್. ವೈ ಯು ಹ್ಯಾವ್ ಟು ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್ ದ ರೇ ಡಯಾಗ್ರಾಮ್. ರೇ ಡಯಾಗ್ರಾಮ್ ನಿಮಗೆಲ್ಲ ಗೊತ್ತಿದೆ ಅನ್ಕೊಂಡಿದ್ದೀನಿ. ವೈ ವಿ ಹ್ಯಾವ್ ಟು ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್ ರೇ ಡಯಾಗ್ರಾಮ್ಸ್? ಟು ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್ ದ ಮ್ಯಾಗ್ನಿಫಿಕೇಶನ್ ಅಂಡ್ ದ ಪ್ರಾಪರ್ಟೀಸ್. ನೌ concave mirror. What is the speciality of concave mirror? You see the first ray diagram. Any parallel ray, ದೂರದಿಂದ ಬರ್ತಿರೋ ರೇಸ್, ದೂರದಿಂದ ಬರ್ತಿರೋ ರೇಸ್ ಆರ್ ಪ್ಯಾರಲಲ್ ರೇಸ್. They'll hit the mirror, they'll reflect. They'll reflect and go where? They'll come to a common point, and that common point is called as F. Okay, this is one property, one thing that we understood from the ray diagram. Next, you see B1. You're getting a real image, real and inverted ಉಲ್ಟಾ ಇಮೇಜ್. ರಿಯಲ್ ಕನ್ನಡಿ ಒಳಗಡೆ ಅಲ್ಲ, ಕನ್ನಡಿ ಆಚೆ ರಿಯಲ್ ಇಮೇಜ್ ಬರ್ತಾ ಇದೆ, ಉಲ್ಟಾ ಬರ್ತಾ ಇದೆ. ನೆಕ್ಸ್ಟ್ ಸಿ ನೋಡಿ, ಸಿ ಅದು ಕೂಡ ಉಲ್ಟಾ ಬರ್ತಾ ಇದೆ. ಡಿ ನೋಡಿ, ಅದು ಕೂಡ ಬರ್ತಾ ಇದೆ. ಸಿ ಕೂಡ ಬರ್ತಾ ಇದೆ, ಇದು ಎ ಬಿ ಡಿ ಇ. ಎಫ್ ನೋಡಿ, ಏನಿದೆ ಎಫ್? ಸ್ಪೂನ್ ತಗೊಂಡ್ರೆ ಸ್ಪೂನ್ ತಗೊಳ್ಳಿ ನಿಮ್ಮ ಮನೇಲಿ, ಹತ್ರ ಬಂದ್ಬಿಡಿ ಸ್ಪೂನ್ ತಗೊಂಡು, ಆ ಕರ್ವ್ಡ್ ಪಾರ್ಟ್, ಯುವರ್ ಫೇಸ್ ವಿಲ್ ಬಿಕಮ್ ಬಿಗ್. So only at one position, remember, only at the last position, that is between F and P, you will get a virtual image, virtual kannadi hinde, and an erect image, and an enlarged image. Remember this point very clearly, remember, let it go to your brains. Only one mirror where you get virtual erect and enlarged. Virtual erect plane mirror allu barutte. Virtual agide, erect agide, ಆದ್ರೆ enlarge ಆಗಲ್ಲ, ಸೇಮ್ ಸೈಜ್ ಇರುತ್ತೆ. ಆದರೆ ಈ ಮಿರರ್ ಸ್ಪೆಷಾಲಿಟಿ ಏನಂದ್ರೆ, ಇಟ್ ವಿಲ್ ಬಿ ವರ್ಚುವಲ್, ಇಟ್ ವಿಲ್ ಬಿ ಎರೆಕ್ಟ್, ಅಂಡ್ ಇಟ್ ವಿಲ್ ಬಿ ಎನ್ಲಾರ್ಜ್. ವಿಚ್ ಪೊಸಿಷನ್? ಓನ್ಲಿ ಒನ್ ಪೊಸಿಷನ್ ಬಿಟ್ವೀನ್ ಎಫ್ ಅಂಡ್ ಪಿ. ಇಫ್ ಯು ಕೀಪ್ ಎ ಕ್ಯಾಂಡಲ್ ಆರ್ ಯು ಗೋ ಕ್ಲೋಸರ್, ಇಟ್ ವಿಲ್ ಬಿಕಮ್ ಬಿಗ್. ಓಕೆ, ನೆಕ್ಸ್ಟ್ ಟೂ ಮೋರ್ ಡಯಾಗ್ರಾಮ್ಸ್ ಹಿಯರ್. ವಾಟ್ ಆರ್ ದಿಸ್ ಟೂ ಮೋರ್ ಡಯಾಗ್ರಾಮ್ಸ್ ಫಾರ್? ದಿಸ್ ಇಸ್ ಯುವರ್ ಕಾನ್ವೆಕ್ಸ್ ಮಿರರ್ಸ್. ಕಾನ್ವೆಕ್ಸ್ ಮಿರರ್ ಏನೇ ಮಾಡು, ಎಲ್ಲಾರು ಇಟ್ಕೋ ಗುರು, ನೀನು ಎಷ್ಟೇ ದೂರದಲ್ಲಿ ಇಡು, ಎಷ್ಟೇ ಹತ್ರ ಇಡು, ವೇರ್ ಎವರ್ ಕೀಪ್, always you get a small image. It is virtual, it is erect, but diminished, smaller one. Now remember, now tell me, which is the mirror? Okay, now remember, which is the mirror again? Which is the mirror which always produces virtual, erect and diminished image? ಯಾರು ಮಾಡಲ್ಲ, ಕಾನ್ವೆಕ್ಸ್ ಮಾತ್ರ ಮಾಡೋದು. only convex mirror. So virtual, erect and same size, plain mirror. Virtual, erect and enlarged, concave mirror. Virtual, erect and diminished, that is your convex mirror. So these things I understood using the ray diagram. Now one by one properties I already explained. Concave eno, curved, inverts, kannadi illide, focus is in front of it. Okay, focus is, one second, focus is in front of this, all hitting, focus is front of mirror. Next I told you, e mirror it will also produce real image, virtual image also, magnified also, diminished also. Okay, and only mirror, only one mirror in the history that we have which produces virtual and enlarged is concave. And now tell me, what is magnification? ಇದು ಅರ್ಥ ಆಗ್ಬೇಕು ನಿಮಗೆ. ಮ್ಯಾಗ್ನಿಫಿಕೇಶನ್ ಅಂದ್ರೆ ದೊಡ್ಡದಾಗೋದು, ಚಿಕ್ಕದಾಗೋದು. ಏನಾಗುತ್ತೆ ಈ ಮಿರರ್ ಅಲ್ಲಿ? ಚಿಕ್ಕದು ಆಗುತ್ತೆ, ದೊಡ್ಡದು ಆಗುತ್ತೆ, ಸ್ಟ್ರೈಟ್ ಆಗು ಆಗುತ್ತೆ. ದಟ್ ಮೀನ್ಸ್ ದ ಮ್ಯಾಗ್ನಿಫಿಕೇಶನ್ ವ್ಯಾಲ್ಯೂಸ್ ಫಾರ್ ಕಾನ್ಕೇವ್ ಮಿರರ್ ಕ್ಯಾನ್ ಬಿ +1, can it be +2? Yes, it can be. Why? I told you, we come closer between F and P, what will happen? You get an enlarged image, virtual image. Plus andre straight, virtual plus andre straight agi barutte yavaga, dappa agutte yavaga, between F and P. So this mirror, the magnification value can be +2, +3, +4. Can it be -3? Yes, it can be -3. ಕೆಳಗಡೆ ಬರುತ್ತೆ, ಮೈನಸ್ ಅಂದ್ರೆ ಕೆಳಗಡೆ ಬರುತ್ತೆ, ದೊಡ್ಡದಾಗುತ್ತೆ. Okay, so only mirror where magnifications can be minus and also plus, okay, is your concave mirror. Then your uses you already know. ಸೋಲಾರ್ ಫರ್ನೆಸ್ ಈಗಾಗಲೇ ಅದು ಅರ್ಥ ಆಗಿದೆ, ನಾನು ಯೂಸ್ ಗೊತ್ತಾಗುತ್ತೆ. ಎಲ್ಲ ರೇ ಹೊಡೆದು ಬಿಟ್ಟು ಫೋಕಸ್ ಮೇಲೆ ಬರುತ್ತೆ, ಫೋಕಸ್ ಅಲ್ಲಿ ಒಂದು ಕುಕ್ಕರ್ ಇಟ್ಬಿಟ್ರೆ ಕುಕ್ಕರ್ ಅಲ್ಲಿ ಅಡಿಗೆ ಆಗುತ್ತೆ. ನೆಕ್ಸ್ಟ್ ಡೆಂಟಿಸ್ಟ್, ಹಲ್ಲು ದೊಡ್ಡದಾಗ ಕಾಣಿಸುತ್ತೆ, ಯಾವಾಗ ನೋಡ ಹತ್ರ ತಗೊಂಡೋಗ್ಬೇಕು, ಬಿಟ್ವೀನ್ FNP ಮತ್ತೆ ದೊಡ್ಡದಾಗೋದು, ಹತ್ರ ತಗೊಂಡು ಹೋಗ್ತಾನ ಅವನು. ಓಕೆ, ಲಾಸ್ಟ್ಲಿ ದಿಸ್ ಒನ್, ಸಿ ದಿಸ್ ಬಲ್ಬ್, ವಾಟ್ ಇಸ್ ದಿಸ್? ಹೆಡ್ಲೈಟ್. ಉಲ್ಟಾ ನಾವು, all the ray coming from parallel rays hitting the mirror go to focus. Now you keep a bulb at focus, it will hit the glass, hit the mirror and go parallel. Okay, and lastly you know the shaving mirror, ನೋಡಿ ಹತ್ರ ಬಂತ ದೊಡ್ಡದು ಕಾಣಿಸುತ್ತೆ, ಹತ್ರ ಬಂದ ತಕ್ಷಣ ದೊಡ್ಡದು ಕಾಣಿಸುತ್ತೆ, ಯಾವ್ದ್ರಲ್ಲಿ? ನಿಮ್ಮ concave mirror ಅಲ್ಲಿ. So these are the uses, you should understand this. They can ask different ways. Convex mirror, very simple. Convex mirror, it is ಈ ತರ ಕನ್ನಡಿ ಇಲ್ಲಿದೆ, bulge curved outwards, focus is ಬಿಹೈಂಡ್. ಫೋಕಸ್ ಎಲ್ಲಿರುತ್ತೆ? ಇದು ನಾನು ಹೇಳಿದೆ, ಒಂದು ದೊಡ್ಡ ಸಿರಿ ಇದಿದೆ, ಫುಟ್ಬಾಲ್ ಕಟ್ ಮಾಡ್ತೀನಿ, ಒಳಗಡೆ ಎಲ್ಲಿದೆ? ಮೊದಲು ಸೆಂಟರ್ ಎಲ್ಲಿತ್ತು? ಒಳಗಡೆನೆ ಇತ್ತು ಸೆಂಟರ್. ಫೋಕಸ್ ಇಲ್ಲ, ಅದು ಕೂಡ ಇಲ್ಲೇ ಇದೆ. ಫೋಕಸ್ ಇಸ್ ಬಿಹೈಂಡ್ ದ ಮಿರರ್ ಅಂಡ್ ಓನ್ಲಿ, ಆವಾಗಲೇ ಹೇಳಿದೆ ಇವಾಗಲೇ ಹೇಳ್ತಾ ಇದ್ದೀನಿ, ಓನ್ಲಿ ಮಿರರ್ ಟು ಪ್ರೊಡ್ಯೂಸ್ ವರ್ಚುವಲ್ ಡಿಮಿನಿಸ್ಡ್ ಇಮೇಜ್, ವರ್ಚುವಲ್ ಎಲೆಕ್ಟ್ ಡಿಮಿನಿಸ್ಡ್ ಇಸ್ ಕಾನ್ವೆಕ್ಸ್. ದೆನ್ ಟೆಲ್ ಮಿ, ವಾಟ್ ಆರ್ ದ ಪಾಸಿಬಲ್ ವ್ಯಾಲ್ಯೂಸ್ ಆಫ್ ಮ್ಯಾಗ್ನಿಫಿಕೇಶನ್? ಕ್ಯಾನ್ ಇಟ್ ಬಿ ನೆಗೆಟಿವ್? ನೋ. ನೆಗೆಟಿವ್ ಆಗ್ಬೇಕಂದ್ರೆ ಉಲ್ಟಾ ಬರಬೇಕು, ರಿಯಲ್ ಆಗ್ಬೇಕು. ಮುಂದೆ ಬರುತ್ತಾ? ಬರಲ್ಲ. ಓನ್ಲಿ ಒನ್ ಆಪ್ಷನ್, ಇಟ್ ವಿಲ್ ಆಲ್ವೇಸ್ ಬಿ ಪ್ಲಸ್. ಬಟ್ ವಿಲ್ ಇಟ್ ಗೋ ಮೋರ್ ದೆನ್ ಒನ್? It will never go more than 1. The values will never go more than, will always be, for example, plus 0.8, plus 0.7, plus 0.9, or plus 1/3, less than 1. Okay, so these are the properties you have to properly understand. You will get a 1 mark question. Next, convex, you know, where rear view mirrors, ಡ್ರೈವರ್ ಮೇಲೆ ಒಂದು ಕನ್ನಡಿ ಇರುತ್ತೆ, ಹಳ್ಳಿಗಳಲ್ಲಿ ಬ್ಲೈಂಡ್ ಟರ್ನ್ಸ್, ಪಾರ್ಕಿಂಗ್ ಲಾಟ್ಸ್ ಅಲ್ಲೆಲ್ಲ ಇರುತ್ತೆ, ಎಲ್ಲ ಕಾಣಿಸ್ಬೇಕು ಅಂತ. These are use of convex mirror. Why convex mirror we use? Why? Because it produces a wide angle view and diminished image, wide angle diminished erect virtual image. Okay, so ನೋಡಿ ಇಲ್ಲಿ ಕನ್ನಡಿಯಲ್ಲಿ ಕಾಣಿಸ್ತಾ ಇದೆ, ಡ್ರೈವರ್ಗೆ ಇಡೀ ರೋಡ್ ಎಲ್ಲ ಕಾಣಿಸುತ್ತೆ. Okay, next, what is magnification? I already explained. Magnification is height of image by height of object. Plane mirror magnification is 1. How? I am 170 centimeters. I am 170 centimeters. I'll stand in front of plane mirror. Will my height change? No. So I am inside the mirror now. My image. What is the height of image? 170 centimeter only. What is the height of object? 170 only. Divide both. 1 plus 1. Okay. Same way. And I already explained. Concave mirror magnification can be negative and positive. Convex, always positive and always less than 1. ಆಮೇಲೆ ಇದನ್ನು ಎಕ್ಸ್ಪ್ಲೇನ್ ಮಾಡಿದ್ದೀನಿ. ಪ್ಲಸ್ ಅಲ್ಲಿ ಇದ್ರೆ ಏನರ್ಥ? ಅದು ವರ್ಚುವಲ್ ಇಮೇಜ್, ಎರೆಕ್ಟ್ ಇಮೇಜ್. ನೆಗೆಟಿವ್ ಇದ್ರೆ ಏನು? ರಿಯಲ್ ಅಂಡ್ ಇನ್ವರ್ಟೆಡ್. ಸೊ ಆ ಕಾನ್ಸೆಪ್ಟ್ ಕೂಡ ಇದರಲ್ಲಿ ಕ್ಲಿಯರ್ ಆಗಿದೆ ಈ ಒಂದು ಸ್ಲೈಡ್ ಅಲ್ಲಿ. ನೆಕ್ಸ್ಟ್ ವಿಲ್ ಗೋ ಟು ರಿಫ್ರಾಕ್ಷನ್. ನಿಮ್ಗೆಲ್ಲ ಗೊತ್ತು, ಪೆನ್ಸಿಲ್ ಮನೆ ಕೊಟ್ಟಿದ್ರು. ಯಾಕೆ ಪೆನ್ಸಿಲ್ ಬೆಂಡ್ ಆಗುತ್ತೆ? ಏನೇನೋ ಬರ್ದಿದ್ರು, ತುಂಬಾ ಇದೆಲ್ಲ ಆಯಿಲ್ ಹಾಕಿರ್ತಾರೆ ಅದ್ರೊಳಗಡೆ, ಅದು ಏನೋ ಇನ್ನೇನೋ ಅದರಲ್ಲಿ ಇದು ಏರ್ ಮಿಕ್ಸ್ ಆಗಿ ಮಾಡ್ಬಿಟ್ರಿ, ಏನೇನೋ ಬರ್ದಿದ್ರು ಕತೆಗಳು. ಏನು ಇಲ್ಲ, ಇಟ್ ಇಸ್ ಬಿಕಾಸ್ ಆಫ್ ರಿಫ್ರಾಕ್ಷನ್. ಓಕೆ, ಇದೊಂದು ನೋಡಿ, ಕಾಯಿನ್ ಹಾಕಿದ್ದಾರೆ. ಮೇಲಿಂದ ನೋಡಿದ್ರೆ ಸ್ವಿಮ್ಮಿಂಗ್ ಪೂಲ್ ಅಲ್ಲಿ ಎಕ್ಸ್ಪೀರಿಯನ್ಸ್ ಮಾಡಿ. ಇಫ್ ಯು ಗೋ ಟು ಸ್ವಿಮ್ಮಿಂಗ್ ಪೂಲ್, ಯು ಜಸ್ಟ್ ಸಿ ಫ್ರಮ್ ಟಾಪ್ ಅಂಡ್ ಡಿಸೈಡ್ ದ ಡೆಪ್ತ್, ಯು ಆರ್ ರಾಂಗ್, ಯು ಆರ್ ಡೆಡ್. ಅಂದ್ರೆ ಸತ್ತೋಗ್ಬಿಡ್ತೀವಿ ನೀವು. ಮೇಲಿಂದ ನೋಡಿದ್ರೆ ಆಳ ಇಲ್ಲ ಅನ್ಸುತ್ತೆ, ಯು ವಿಲ್ ಫೀಲ್ ದಟ್ ಇಟ್ ಇಸ್ ನಾಟ್ ವೆರಿ ಡೀಪ್. ಬಟ್ ಇಫ್ ಯು ಗೋ ಇನ್ ಸೈಡ್, ಯು ವಿಲ್ ಫೀಲ್ ವೆರಿ ಡೀಪ್. ಸೊ ದಟ್ ಈಸ್ ಬಿಕಾಸ್ ಆಫ್ ರಿಫ್ರಾಕ್ಷನ್ ಅಗೇನ್. Okay, so what is refraction? Light will bend. You know what is light speed? You know what is the speed of your Vande Bharat train? It is 180 km/h. Bullet train 500 km/h. You can go to Goa in 1 hour. You know what is the speed of your light? It is 3 lakh km/s. In 1 second it will go how much? 3 lakh km. How much? 3 lakh km in 1 second. That is the speed of light. That the speed of light, that is in vacuum. But when this same light goes inside water, it will decrease the speed. It goes inside diamond, decrease the speed. It will go, speed decrease ಆಗಬೇಕಂದ್ರೆ ಯಾಕೆ ಡಿಕ್ರೀಸ್ ಆಗಬೇಕು? ಗಾಡಿಲಿ ಹೋಗ್ತಾ ಇರ್ತೀರಾ, ಸ್ಟ್ರೈಟ್ ಆಗಿ ಹೋಗಿ ರೋಡಲ್ಲಿ ಹೋಗ್ತಿದ್ದೀರಾ, ಒಂದೇ ಸ್ಪೀಡ್ ಹೋಗ್ತಿದ್ದೀರಾ. ಗಾಡಿ ಸ್ಲೋ ಮಾಡಿದ್ರೆ ಯಾಕೆ ಸ್ಲೋ ಮಾಡ್ತೀರಾ? ಮೆಜಾರಿಟಿ ಟೈಮ್ ಯು ಸ್ಲೋ ಬಿಕಾಸ್ ದೇರ್ ಇಸ್ ಎ ಹಂಪ್ ಆರ್ ದೇರ್ ಇಸ್ ಎ ಕರ್ವ್. When you want to change the direction, you reduce the speed. So whenever the change in the direction and the speed of light, when the light enters from one medium to another medium, when the light enters from air to glass, from glass to water, from water to glass, different medium, it will change the direction. Obviously, when you change the direction, speed also will change. And this process is called as refraction. Laws of refraction. Okay, these are both the laws of refraction. First law you know, second law you know. Second law, remember, it is also called as Snell's law. They will ask, what is Snell's law? You have to explain the Snell's law. They only write the second law. Okay. ಲಾಸ್ಟ್ಲಿ ಈ ಚಾಪ್ಟರ್ ವೆರಿ ಇಂಪಾರ್ಟೆಂಟ್. ಗ್ಲಾಸ್ ಲ್ಯಾಬ್ ಎಕ್ಸ್ಪೆರಿಮೆಂಟ್ ಏನಿದು ಸಂಭ್ರಮ, ತುಂಬಾ ಜನಕ್ಕೆ ಇದೇನು ಅರ್ಥನೇ ಆಗಲ್ಲ. ನೋಡಿ, ಮೇಲೊಂದು ಡಯಾಗ್ರಾಮ್ ಇದೆ, ಯೂಟ್ಯೂಬ್ ಅಲ್ಲಿ ವಿಡಿಯೋ ಸಿಗುತ್ತೆ ನೋಡಿ ಕಾಮಾಗೆ, ಆಯ್ತಾ? ಅದರದ್ದು ವರ್ಷನ್ ಇಲ್ಲಿದೆ, ಟೆಕ್ಸ್ಟ್ ಬುಕ್ ವರ್ಷನ್. ನೋ ಜಸ್ಟ್ ಸಿ ಇನ್ಸಿಡೆಂಟ್ ರೇ, ರೆಡ್ ಕಲರ್, ಆಬ್ಲಿಕ್ ರೇ. ಫ್ರಮ್ ವೇರ್ ಇಟ್ ಇಸ್ ಕಮಿಂಗ್? It is coming from air. From to where it is going? It is going to the glass. Air to glass. I told you it is different medium. Light glass ಬಂತು, ಸ್ಪೀಡ್ ಕಡಿಮೆ ಮಾಡಬೇಕು, ಆಯ್ತಾ? ಸ್ಪೀಡ್ ಕಡಿಮೆ ಮಾಡಿದಾಗ ಏನಾಗುತ್ತೆ? ಇಟ್ ವಿಲ್ ಕಮ್ ಟುವರ್ಡ್ಸ್ ದ ನಾರ್ಮಲ್. ಯು ಸಿ ದ ರಿಫ್ರಾಕ್ಟೆಡ್ ರೇ, ಇಟ್ ಇಸ್ ಕಮಿಂಗ್ ಟುವರ್ಡ್ಸ್ ದ ನಾರ್ಮಲ್. ಅಗೇನ್ ಇಟ್ ವಿಲ್ ಗೋ ಸ್ಟ್ರೈಟ್, ರೆಡ್ ಕಲರ್. ಗ್ಲಾಸ್ ಇಂದ ಏರ್ಗೆ ಹೋಗ್ಬೇಕು, ಇವಾಗ ಫ್ರೀ ಆಗ್ಬಿಡುತ್ತದು. ಗ್ಲಾಸ್ ಅಲ್ಲಿ ಕಷ್ಟ ಹೋಗಕ್ಕೆ, ಏರ್ ಅಲ್ಲಿ ಫ್ರೀ. ಸೊ ವೆನ್ ಇಟ್ ಕಮ್ ಔಟ್ ಸೈಡ್, it will go away from the normal. Remember this, from denser, from rarer to denser. Rarer andre air, denser andre glass, denser medium. Rarer to denser, come closer. Okay, from closer to normal, from denser to rarer, away from the normal. ದೂರ ಫ್ರೀ ಆಗ್ಬಿಡುತ್ತೆ. ಡೆನ್ಸರ್ ಇಂದ ರೇರರ್ ಹೋದಾಗ ಫ್ರೀ ಆಗಿ ದೂರ ಹೋಗ್ಬಿಡುತ್ತೆ. ಓಕೆ, ಸೊ ನೌ ಇಫ್ ಯು ಸಿ ಒನ್ ಇಂಪಾರ್ಟೆಂಟ್ ಪಾಯಿಂಟ್ ಹಿಯರ್. If at all there was no the glass slab, if there was no glass slab, what will happen to the incident ray? ಸ್ಟ್ರೈಟ್ ಆಗಿ ಬಂದ್ಬಿಡ್ಬೇಕಾಗಿತ್ತು, ಸ್ಟ್ರೈಟ್ ಆಗಿ ಬಂದ್ಬಿಡ್ಬೇಕು. ಡಾಟೆಡ್ ಲೈನ್ಸ್ ನೋಡಿ, ಬಟ್ ಹಿಂಗ್ ಬೆಂಡ್ ಆಗಿ ಎಮರ್ಜೆಂಟ್ ರೇ ಆಗಿ ಆಚೆ ಬರ್ತಿದೆ, ರೆಡ್ ಕಲರ್ ರೇಗೆ ಆಚೆ ಬರ್ತಿದೆ. ಇಫ್ ಯು ಸಿ ದ ಒರಿಜಿನಲ್ ರೇ ಅಂಡ್ ದ ಎಮರ್ಜೆಂಟ್ ರೇ, ಬೋತ್ ಆರ್ ಪ್ಯಾರಲಲ್. ಸಿ ದಟ್ ಬೋತ್ ಆರ್ ಪ್ಯಾರಲಲ್, ಅಂಡ್ ದಟ್ ಡಿಸ್ಟೆನ್ಸ್ ಬಿಟ್ವೀನ್ ದೆಮ್ ಇಸ್ ಕಾಲ್ಡ್ as the lateral displacement. ಗ್ಲಾಸ್ ಇಲ್ಲ ಅಂದ್ರೆ ಸ್ಟ್ರೈಟ್ ಆಗಿ ಬರ್ಬೇಕಾಗಿರೋರ್ನ ಗ್ಲಾಸ್ ಬಂದು ಲೈಟ್ ಬೆಂಡ್ ಮಾಡಿ ಆಚೆ ಬರುತ್ತೆ. ಓಕೆ, ಸೊ ಯು ಹ್ಯಾವ್ ಟು ಪ್ರಾಪರ್ಲಿ ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್ ದಿಸ್ ಕಾನ್ಸೆಪ್ಟ್. ಓಕೆ, ಡೆನ್ಸರ್, ರೇರರ್ ಟು ಡೆನ್ಸರ್, ರೇರರ್ ಟು ಡೆನ್ಸರ್, ಕ್ಲೋಸ್ ಟು ನಾರ್ಮಲ್, ಡೆನ್ಸರ್ ಟು ರೇರರ್, away from the normal. That's all. The same experiment, this they asked, explain the activity to show the refraction through the glass slab. ಈ ಎಕ್ಸ್ಪೆರಿಮೆಂಟ್ ನ ನೀವು ಓದಬೇಕು, ಟೆಕ್ಸ್ಟ್ ಬುಕ್ ಅಲ್ಲಿ ಇದೆ, ಮಾಡೆಲ್ ಪೇಪರ್ ಅಲ್ಲಿ ಕೇಳಿದ್ದಾರೆ, ಕೇಳ್ಬಿಡ್ಬೋದು ಎಕ್ಸಾಮ್ ಅಲ್ಲಿ. ಈಸಿ ಇದೆ, ತುಂಬಾ ಏನ್ ಕಷ್ಟ ಇಲ್ಲ. ಯೂಟ್ಯೂಬ್ ಅಲ್ಲಿ ವಿಡಿಯೋ ಸಿಗುತ್ತೆ ನೋಡಿ ಹೆಂಗ್ ಮಾಡೋದು ಅಂತ. ಈ ಮೇಲಿದೆಯಲ್ಲ ಅದನ್ನ ಹೆಂಗ್ ಮಾಡಿ, ಈ ಎಕ್ಸ್ಪೆರಿಮೆಂಟ್ ಹೆಂಗ್ ಮಾಡೋದು ಅಂತ. ಸೇಮ್ ಲೈಕ್ ಯುವರ್ ದಟ್ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಲೈನ್ಸ್ I explained, I showed you one video now. Like it, you'll get many videos, you see. Next points, remember whatever I said. Rarer to denser, okay, it will go away from the normal. Okay, so from glass to air, denser to rarer, it goes away, away from the normal. These same points, whatever I explained, I just put it briefly. Important points to remember from this outcome, from this activity. Next, this one, refractive index. Again, everybody confusing. Optical density, speed. What is refractive index? Light bend ಆಗುತ್ತೆ ಹೇಳಿದೆ, ಎಷ್ಟು ಬೆಂಡ್ ಆಗುತ್ತೆ ಅನ್ನೋದಕ್ಕೆ ವ್ಯಾಲ್ಯೂ ಬೇಕು, ವ್ಯಾಲ್ಯೂ. Refractive index tells you how much light is bending, how much it is bending. Now, if I tell you the refractive index is 2.42, the meaning is it is bending so much times ಅಂತ ಅರ್ಥ ಮಾಡ್ಕೊಳ್ಳಿ. Okay, next, refractive index and optical density is almost same. What is optical density? What is density? All the atoms are closer, very closer. That is density, you know. Same way it is, similar analogy is optical density. More the optical density, more the refractive index. If you see your textbook, I'll come to this table. Diamond nodi 2.42. More the optical density, more the refractive index, more the optical density. Now if somebody asks ice, water and diamond, who has more optical density? It is diamond, because more refractive index, more optical density. Between ruby, sapphire and diamond, who has less optical density? Who has less? Directly proportional. I told you, like your resistance and length, directly proportional. Same way, your refractive index and optical density are both same, direct. Idu bedre idu beliyutte, same. But very important point, that is your speed. What is speed? Inversely proportional to refractive index. So now going back to this table, remember, more the refractive index, lesser the speed of light. Andre 2.42 ರಿಫ್ರಾಕ್ಟಿವ್ ಇಂಡೆಕ್ಸ್ ಅಂದ್ರೆ ತುಂಬಾ ಬೆಂಡ್ ಮಾಡಿಬಿಡುತ್ತೆ ಲೈಟ್ ಅಂತ. ತುಂಬಾ ಬೆಂಡ್ ಆಗುತ್ತೆ ಅಂದ್ರೆ ಸ್ಪೀಡ್ ಕಡಿಮೆ ಆಗ್ಲೇಬೇಕು. ನಾವು ಟೆಲ್ ಮಿ ಬಿಟ್ವೀನ್ ಬೆನ್ಸಿನ್ and rock salt, between benzene and rock salt, if somebody asks where is the speed of light highest, benzene or rock salt, anybody can tell it is benzene. Why? 1.50 refractive index. Lesser the refractive index, lesser the bending. So easily higher the speed ಚೆನ್ನಾಗಿ ಹೋಗುತ್ತೆ, easily ಹೋಗುತ್ತೆ, inversely proportional. This one you need to understand. Okay, so and this definition, what is absolute refractive index? Definition you have to read. Next important definitions: aperture, optic center, power of lens. Okay, there are other definitions also, but these are high important, high priority. Power of lens. What is power of lens? Very simple. Power of lens is reciprocal of focal length. Okay, now to very important, you should understand this. Convex lens. In convex lens, the focal length is positive. Wherever you see this convex mirror or convex lens, always focal length is positive. Our eyes is, we have convex lens positive. Remember, we are positive, our eyes is positive. Convex, any convex, it is positive. If the focal length is positive, power of lens is just the reciprocal of 1 by f. It also will be positive. Convex lens, power positive. Concave lens, power negative. If somebody I have given one example. If a person prescription is plus D diopter, D and the diopter, then they're using what? Convex lens. If his prescription is minus 2.5D, then they're using concave lens. ಇದನ್ನ connect ಮಾಡ್ತಾರೆ next chapter ಅಲ್ಲಿ ಹೇಳ್ತೀನಿ ಹಿಂಗೆ ಅಂತ. Lastly, SI unit of power is diopter and power is equal to 1 by f. Here, very important. F stands for what? F stands for focal length in what? Focal length in meters. ಎಕ್ಸಾಮಲ್ಲಿ ಟೆಸ್ಟ್ ಅಲ್ಲಿ ಎಕ್ಸಾಮಲ್ಲಿ ಏನ್ ಮಾಡ್ಬಿಡ್ತಾರೆ, ಫೋಕಲ್ ಲೆಂತ್ ನ ಸೆಂಟಿಮೀಟರ್ ಅಲ್ಲಿ ಕೊಡ್ತಾರೆ. ನೀವು ಹಂಗೆ ಸಿಂಪ್ಲಿಫೈ ಮಾಡಿಬಿಟ್ರೆ, ಇಫ್ ದೇ ಗಿವ್ 50 ಸೆಂಟಿಮೀಟರ್ is the focal length, find the power. 1 by 50 ಅಂತ ಮಾಡಿಬಿಟ್ರೆ you are wrong. 50 centimeter in meters convert, it is 0.5. 1 by 0.5 ಮಾಡಿ, that is the answer for power of lens. If they give in meters, well and good, very happy, just divide it by 1. But if they give in centimeters, no, then you have to convert to meters and then simplify. Okay, we'll go to the last chapter. Already we have crossed 6 minutes. Okay, so human eye and colorful world, very simple chapter, only 5 marks. Firstly, human eye. Everybody know human eye? Okay, so retina is a screen that is there behind where the image we get. Okay, some important points. Cornea, first part, current alle, this they will ask, where the refraction of light happens. Refraction, where? Cornea it happens. Who decide the color of our eyes? Color, kelu green color eyes antivi, kelu brown eyes antivi. Yaru? Iris decide ಮಾಡ್ತಾರೆ, iris. Okay, ಎಷ್ಟು ಲೈಟ್ ಹೋಗ್ಬೇಕು ಕಣ್ಣೊಳಗಡೆ ಎಷ್ಟು ಲೈಟ್ ಹೋಗ್ಬೇಕು? If you see the cat eyes, you can very clearly observe it. Who will decide that? How much light to go? Pupil will decide. Lens, you know. Ciliary muscle, what is this ciliary muscle or ciliary muscles? That is the muscle that will make your lens bigger and smaller. Retina, I told you, behind the screen. And in retina, remember this point, image formed in retina is always real and inverted. Sir, then whatever we are seeing, why are we seeing straight then? You're telling real and inverted. Yes, it is inverted only. It falls on our retina inverted. But our brain, understand, it sets positive. It makes it erect. Optic nerves will transmit signals to brain. So these are the points regarding human eye you should remember. Next, power of accommodation. What is this power? If you go to a shop and ask, if you're a photographer friend you have, or you're interested in photography, if you want to capture a photo of a long distance object, then the focal length should be more focal length. Your lens should be very thin. See these two diagrams here. First diagrams, it is thin. Second diagram lens, it is fat. Thin and fat, long and fat. Thin agidre odadbiಟ್ಟು ದೂರಕ್ಕೆ ಹೋಗ್ಬಿಡುತ್ತೆ. It is very far. So anybody wants to capture tiger ಹತ್ರ ಹೋಗಿ ಇಡಕ್ಕಾಗಲ್ವಲ್ಲ, ದೂರದಿಂದನೇ ಫೋಟೋ ಹಿಡಿಬೇಕಲ್ಲ. ಸೊ the lens should be of more focal length. ಹತ್ರದ್ದು ಉಳದ ಫೋಟೋ ಹಿಡಿಬೇಕು, ಫೋಕಲ್ ಲೆಂತ್ ಕಡಿಮೆ ಆಗ್ಬೇಕು, ದಪ್ಪ ಆಗ್ಬೇಕು. ಅವನು ಲೆನ್ಸ್ ಚೇಂಜ್ ಮಾಡ್ತಾರೆ. ಯಾರು ಲೆನ್ಸ್ ಚೇಂಜ್ ಮಾಡ್ತಾರೆ? ಲೆನ್ಸ್ ಚೇಂಜ್ ಮಾಡಕ್ಕೆ ಕ್ಯಾಮ್ರಾಮನ್ಗೆ ಲೆನ್ಸಸ್ ಇರುತ್ತೆ. ನಮ್ಮ ಕಣ್ಣಿಗೆ ದೂರದ್ದು ಕಾಣಿಸುತ್ತೆ, ಹತ್ರದ್ದು ಕಾಣಿಸುತ್ತೆ. ಹೆಂಗ್ ಕಾಣಿಸ್ತಾ ಇದೆ ಲೆನ್ಸ್ ಚೇಂಜ್ ಮಾಡದೆ? ಬಿಕಾಸ್ ವಿ ಹ್ಯಾವ್ ದಟ್ ಪವರ್ ಆಫ್ ಅಕಾಮಿಡೇಷನ್. ಹೂ ಡಸ್ ದಟ್? our ciliary muscles. If you want to see something very, 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 very far, okay, I'm seeing very far object, what will happen? My ciliary muscles are free, relaxed. It becomes thin, like the first image here. You can see far point. Calm, it does not shrink. It is calm, relaxed. I can see far thing. My lens is no very, very thin like this. Okay, I can see. But if I want to see closer thing, I want to see the screen, what will happen? It will become thick, it will become fat. Okay, so what will happen? The focal length reduces. Focal length kadme agbidutte. So now next point, what is the near point? Andre clear age you can see something very clearly after 25 centimeter and up to infinity. So what is the range of human hearing range? 9th ಅಲ್ಲಿ ಓದಿದ್ರೆ ಹಿಯರಿಂಗ್ ರೇಂಜ್ 20 ಹರ್ಟ್ಸ್ ಟು 20 ಕಿಲೋ ಹರ್ಟ್ಸ್. ಆ ಸೌಂಡ್ ಮಾತ್ರ ಕೇಳಿಸುತ್ತೆ. ಹಂಗೆ ನಮಗೆ ಕಾಣಿಸೋದು ಏನು? Viewing range is 25 centimeter to infinity. Far point is, near point is 25, far point is infinity. So this one you should understand. They might ask how our eyes accommodates. ಬರೇ ಪವರ್ ಆಫ್ ಅಕಾಮಿಡೇಷನ್ ಬಯಾಟ್ ಹೊಡೆದು ಬಿಟ್ರೆ ಇದು ಅರ್ಥ ಮಾಡ್ಕೊಳ್ಳಿಲ್ಲ ಅಂದ್ರೆ ನೀವು ಓದ್ರಿ, ಅರ್ಥ ಮಾಡ್ಕೊಳ್ಬೇಕು. ಇಟ್ ಇಸ್ ವೆರಿ ಸಿಂಪಲ್. Defects, everything put in one table here. You know myopia, hypermetropia, that all you know. Other names you know. What are the reasons you know? Now one indirect question I will ask. Okay, a doctor has prescribed minus 2D diopter lens for a patient. What is the lens he is using and what is the eye defect? See here, to answer this you want two concepts. Power concept, negative or positive. Next to ಯಾವ ಲೆನ್ಸ್ ಯೂಸ್ ಮಾಡ್ತೀವಿ ಮಯೋಪಿಯಾಗ ಅಂತ. ಇಟ್ ಇಸ್ ಎನ್ ಅಪ್ಲಿಕೇಶನ್ ಬೇಸ್ಡ್ ಕ್ವಶನ್. -2D ಅಂದ್ರೆ ನೆಗೆಟಿವ್ ಅಂದ್ರೆ ಕಾನ್ಕೇವ್ ಲೆನ್ಸು. ಕಾನ್ಕೇವ್ ಯಾರು ಯೂಸ್ ಮಾಡ್ತೀವಿ? ಕಾನ್ಕೇವ್ ಮಯೋಪಿಯಾಗ ಯೂಸ್ ಮಾಡ್ತೀವಿ ಅಷ್ಟೇ. ಓಕೆ, ಆ ತರ ನಿಮ್ಗೆ ಅದಕ್ಕೆ ಎಕ್ಸಾಂಪಲ್ ಕೊಟ್ಟಿದ್ದೀನಿ. ಇದನ್ನ ನೀಟಾಗಿ, ಇಟ್ ಇಸ್ ಆಲ್ರೆಡಿ ಯು ನೋ. ಪೆಸ್ಬಯೋಪಿ ಆಲ್ಸೋ ಯು ಕ್ಯಾನ್ ಗಿವ್. ಇಟ್ ಇಸ್ ಓಲ್ಡ್ ಏಜ್ ಪ್ರಾಬ್ಲಮ್. ಓಕೆ, ಸೊ ದಿಸ್ ಥಿಂಗ್ಸ್, ದಿಸ್ ಎಂಟೈರ್ ಟೇಬಲ್, ಇಫ್ ಯು ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್, two reasons you should know. This diagram you know. See myopia, from far it is coming. ಮಯೋಪಿಯಾ ಡಿಫೆಕ್ಟ್ ಇರೋರಿಗೆ ಏನಾಗುತ್ತೆ ನೋಡಿ, ರೆಟಿನಾ ಮೇಲೆ ಬೀಳ್ತಾ ಇಲ್ಲ. ಇಲ್ಲಿ ನೋಡಿ, ರೆಟಿನಾ ಮುಂದೆ ಬೀಳ್ತಾ ಇದೆ. ದೇ ಕ್ಯಾನ್ ಆಸ್ಕ್ ಎ ಡಯಾಗ್ರಾಮ್ ಬೇಸ್ಡ್ ಕ್ವಶನ್. ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್ ದಿಸ್ ಪ್ರಾಪರ್ಲಿ. ರೇಸ್ ಆರ್ ಕಮಿಂಗ್ ಫ್ರಮ್ ಫಾರ್ ಪಾಯಿಂಟ್. ಲಾಸ್ಟ್ ಬೆಂಚ್ ಅಲ್ಲಿ ಕೂತ್ಕೊಂಡಿದ್ಯಾ? ಲಾಸ್ಟ್ ಬೆಂಚ್ ಅಲ್ಲಿ ಕೂತ್ಕೊಂಡಿದ್ಯಾ? ನಿಂಗೆ ಬೋರ್ಡೇ ಕಾಣಿಸ್ತಿಲ್ಲ ಸರಿಯಾಗಿ. ಮಯೋಪಿಯಾ, ನಾನು ಮಯೋಪಿಕ್ ಪೇಷಂಟ್. ವೈ? ಆಲ್ ದ ರೇಸ್ is not falling on the retina, it is falling in front of retina somewhere else. Gone. I cannot see things properly. So now what should we do? Somebody has to deviate this rays, diverge this rays. Who is diverging? The diverging lens. Who is other name of diverging lens? It is the concave lens. Nodi, concave lens ittaga correct ಆಗಿ ಹಿಂದೆ ಹೋಗಿ ಬೀಳುತ್ತೆ. ಹೈಪರ್ಮೆಟ್ರೋಪಿಯಾ ಹತ್ರದ ಕಾಣಿಸಲ್ಲ, ಯಾಕಂದ್ರೆ it is falling, the image is falling behind the retina. So what to do? Just converge the rays. Converge ಮಾಡಕ್ಕೆ ಯಾರು ಬೇಕು? ನಿಮ್ಗೆ ಗೊತ್ತು, ಕಾನ್ವೆಕ್ಸ್ ಲೆನ್ಸ್ ಬೇಕು. ಸೊ ದಿಸ್ ಇಸ್ ದ ಡಯಾಗ್ರಾಮ್ ಯು ಹ್ಯಾವ್ ಟು ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್. ದೇ ಕ್ಯಾನ್ ಗಿವ್ ಡಯಾಗ್ರಾಮ್ಸ್ ಬೇಸ್ಡ್ ಆನ್ ಡಯಾಗ್ರಾಮ್ ಬೇಸ್ಡ್ ಕ್ವಶನ್. ಕ್ಯಾಟರಾಕ್ಟ್ ವಯಸ್ಸಾಗಿರೋರಿಗೆ ಆಯ್ತಾ, ಈಗ ಡಿಸೀಸ್ ಬರುತ್ತೆ. ಈ ಎಂಟೈರ್ ಲೆನ್ಸ್ ಕ್ರಿಸ್ಟಲೈನ್ ಆಗ್ಬಿಡುತ್ತೆ, ಮಿಲ್ಕಿ ಆಗ್ಬಿಡುತ್ತೆ, ಕ್ಲೌಡಿ ಆಗ್ಬಿಡುತ್ತೆ, ಒಪೇಕ್ ಆಗ್ಬಿಡುತ್ತೆ. ಯು ಕ್ಯಾನ್ ಸಿ ದ ಇಮೇಜ್. ದಿಸ್ ಮೆಡಿಕಲ್ ಕಂಡೀಷನ್ ಅಕರ್ಸ್ ಮೇಜರ್ಲಿ ಅಟ್ ಓಲ್ಡ್ ಏಜ್ ಪೀಪಲ್ ಬಿಕಾಸ್ ಆಫ್ ಶುಗರ್, ಡಯಾಬಿಟೀಸ್, ಇದೆಲ್ಲದಕ್ಕೂ ಬರುತ್ತದು. ದಿಸ್ ಅಬೌಟ್ ಕ್ಯಾಟರಾಕ್ಟ್. ರಿಮೆಂಬರ್ ದಿಸ್. This one, refraction through glass prism. Understand this. Know the experiment. Very simple. They'll ask angle of deviation. Nodi, angle of deviation ellide? D ellide nodi. Keltare. What is the angle of deviation? HGF is the angle of deviation. Al value kottilla. Value kottidre value bariri aste. D bodlu value kottirtare 45 degree, 60 degree, 70 degree. Just write it. That's all. Okay. So understand this diagram. In the end diagram, this is the, when you pass a light through glass prism. See the red light. ಇಟ್ ಇಸ್ ಗೋಯಿಂಗ್ ಆಬ್ಲಿಕ್ ರೇ, ಸಡನ್ ಆಗಿ ಸ್ಟ್ರೈಟ್ ಆಗ್ಬಿಡುತ್ತೆ, ಆಮೇಲೆ ಮತ್ತೆ ಆಚೆ ಸ್ಟ್ರೈಟ್ ಆಗಿ ಆಚೆ ಬರುತ್ತೆ. ಹೆಂಗೋ ಬೆಂಡ್ ಮಾಡುತ್ತೆ ಪ್ರಿಸಮ್, ಹೆಂಗೋ ಬೆಂಡ್ ಮಾಡುತ್ತೆ ಆಯ್ತಾ. ಅದಕ್ಕೆ ಈ ಆಕ್ಟಿವಿಟಿನ ಅರ್ಥ ಮಾಡ್ಕೊಳ್ಳಿ. ಟೆಕ್ಸ್ಟ್ ಬುಕ್ ಅಲ್ಲಿ ಇದೆ, ತುಂಬಾ ದೊಡ್ಡ ಆಕ್ಟಿವಿಟಿ ಅಲ್ಲ. ದೇ ನಾಟ್ ಆಸ್ ದ ಆಕ್ಟಿವಿಟಿ ಬಟ್ ಆಸ್ ದ ಕಾನ್ಸೆಪ್ಟ್ ಬಿಹೈಂಡ್ ದಿಸ್ ಆಕ್ಟಿವಿಟಿ. ಆಂಗಲ್ ಆಫ್ ಡಿವಿಯೇಷನ್ ದೇ ಲಾಸ್, ಕೈಂಡ್ಲಿ ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್ ದಿಸ್ ಡಯಾಗ್ರಾಮ್. ದಿಸ್ ಡಿ ಇಸ್ ಆಂಗಲ್ ಆಫ್ ಡಿವಿಯೇಷನ್, ಔಟ್ಸೈಡ್ ಒನ್ HGF. ಡಿಸ್ಪರ್ಷನ್, ವಿಚ್ ಕಲರ್ಸ್? ವಿಬ್ಗಾಯರ್, ಕೆಳಗಡೆಯಿಂದ ವಿಬ್ಗಾಯರ್. ಕೆಲವೆಲ್ಲ ಮೇಲಿಂದ ವಿಬ್ಗಾಯರ್ ಅನ್ಕೊಂಡ್ಬಿಟ್ಟಿದ್ದೀರಾ. ಕೆಳಗಡೆಯಿಂದ ನೋಡಿ ಕರೆಕ್ಟಾಗಿ ರೆಡ್ ಕೆಳಗಡೆ ಹೋಗ್ಬೇಕು ಆಯ್ತಾ. ಕೆಳಗಡೆಯಿಂದ ಮೇಲ್ ಬರ್ಬೇಕು ವಿಬ್ಗಾಯರ್. ವೈಟ್ ಲೈಟು ಪ್ರಿಸಮ್ ಒಳಗಡೆ ಹೋದ್ರೆ 7 ಕಲರ್ ಆಗಿ ಆಚೆ ಬರುತ್ತೆ. ಓಕೆ, ಅದರಲ್ಲಿ ಕೆಲವರು ಬಿ ಅಂದ್ರೆ ಬ್ರೌನ್ ಅಂತೆಲ್ಲ ಬರೀತಿದ್ದೀರಾ, ಅದು ಬ್ಲೂ ಕಲರ್, ಬ್ರೌನ್ ಎಲ್ಲ ಬರಲ್ಲ. ಓಕೆ, ಸೊ ವೈಲೆಟ್, ಇಂಡಿಗೋ, ಬ್ಲೂ, ಗ್ರೀನ್, ಯೆಲ್ಲೋ, ಆರೆಂಜ್, ರೆಡ್. ಓಕೆ, ನೆಕ್ಸ್ಟ್ dispersion. This you have to correctly understand. What is dispersion? Splitting up of white light into 7 colors. White light to 7 colors ಆಗುತ್ತೆ ಯಾವಾಗ? Only when it passes through prism. This is called as the dispersion. Now understand properly. You're on table ಕೊಟ್ಟಿದ್ದೀನಿ. Wavelength. What is wavelength? ಒಂದು ವೇವ್ ಸ್ಟಾರ್ಟ್ ಆದ್ರೆ ಎಷ್ಟು ದೂರ ಹೋಗುತ್ತೆ? ಯಾವ್ದಕ್ಕೆ ಜಾಸ್ತಿ ವೇವ್ ಲೆಂತ್? ರೆಡ್ ಲೈಟ್ಗೆ ಜಾಸ್ತಿ ವೇವ್ ಲೆಂತ್. ಸಿ 700 ನ್ಯಾನೋಮೀಟರ್ಸ್. ವೈಲೆಟ್ಗೆ ಕಡಿಮೆ, ತುಂಬಾ ಕಡಿಮೆ, ತುಂಬಾ ದೂರ ಹೋಗಕ್ಕಾಗಲ್ಲ, ತುಂಬಾ ಚಿಕ್ಕ ವೇವ್ ಲೆಂತ್. ಶುರು ಆದ್ರೆ ಸ್ವಲ್ಪ ದೂರ ಮಾತ್ರ ಹೋಗುತ್ತೆ. ರೆಡ್ ಶುರು ಆದ್ರೆ ತುಂಬಾ ದೂರ ಹೋಗುತ್ತೆ. ಆಯ್ತಾ? ಸ್ಪೀಡ್ ಬಿಟ್ಬಿಡಿ. ಬೆಂಡಿಂಗ್ ನೋಡಿ, ಬೆಂಡಿಂಗ್ ಇಂಪಾರ್ಟೆಂಟ್. ಯಾವ ಜಾಸ್ತಿ ಬೆಂಡ್ ಆಗುತ್ತೆ? ವೈಲೆಟ್, more it bends. You can see the diagram here. Bending more, which is red, bending less, red color. What is the position? ಅದು ನಿಮ್ಗೆ ಗೊತ್ತು. ಟಾಪ್ ಅಲ್ಲಿ ಇದೆ ರೆಡ್, ವೈಲೆಟ್ ಬಾಟಮ್ ಅಲ್ಲಿ ಇದೆ. ಓಕೆ, ಸೊ ಸ್ಪೀಡ್ ನಿಮ್ಗೆ ಗೊತ್ತು. ಇವಾಗ ತುಂಬಾ ಬೆಂಡ್ ಆಗಿಲ್ಲ ಅಂದ್ರೆ ಏನರ್ಥ? ಫಾಸ್ಟ್ ಆಗಿದೆ ಅಂತ. ತುಂಬಾ ಬೆಂಡ್ ಆಗಿದೆ ಅಂದ್ರೆ ಏನರ್ಥ? ಸ್ಲೋ ಆಗಿದೆ ಅಂತ. ಲೈಟ್ ಈ ಟೇಬಲ್ ನ ಅರ್ಥ ಮಾಡ್ಕೊಂಡ್ಬಿಟ್ರೆ ಈಸಿಲಿ ಯು ಕ್ಯಾನ್ ಆನ್ಸರ್. ದೆನ್ ನೌ ಟೆಲ್ ಮಿ ವೈ ವಿ ಯು ಶುಡ್ ರೆಡ್ ಕಲರ್. ರೆಡ್ ಕಲರ್ ಫಾರ್ ಡೇಂಜರ್ ಸೈನ್. ವೈ? ದಟ್ ಈಸ್ ಆಬ್ವಿಯಸ್. ಮೋರ್ ದ ಲಾಂಗರ್ ದ ವೇವ್ ಲೆಂತ್ ಸ್ಟಾರ್ಟ್ ಆದ್ರೆ ರೆಡ್ ಕಲರ್ ತುಂಬಾ ದೂರ ಹೋಗುತ್ತೆ. ಸ್ಕ್ಯಾಟರ್ ಕಡಿಮೆ ಆಗುತ್ತೆ. ಅದಕ್ಕೆ ಬರ್ತೀನಿ ನೆಕ್ಸ್ಟ್. ಸ್ಕ್ಯಾಟರಿಂಗ್ ಕಡಿಮೆ ಆಗುತ್ತೆ. ವೈಲೆಟ್ ಟು ಬ್ಲೂ ಕಲರ್ ಜಾಸ್ತಿ ಸ್ಕ್ಯಾಟರ್ ಆಗುತ್ತೆ. ನೆಕ್ಸ್ಟ್ ದಿಸ್ ಡಯಾಗ್ರಾಮ್. ಎವ್ರಿಬಡಿ ನೋ ರಿಕಾಂಬಿನೇಷನ್ ಆಫ್ ವೈಟ್ ಲೈಟ್. ವೈಟ್ ಲೈಟ್ ಬರುತ್ತೆ, ಪ್ರಿಸಮ್ ಅಲ್ಲಿ ಹೋಗುತ್ತೆ, 7 ಕಲರ್ ಆಗುತ್ತೆ, ಮತ್ತೆ 7 ಕಲರ್ ಪ್ರಿಸಮ್ ಅಂತ ವೈಟ್ ಕಲರ್ ಆಗುತ್ತೆ. ಸೊ ದಿಸ್ ಒನ್ ಪ್ರಾಪರ್ಲಿ ಯು ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್. ಇಸ್ ಆಲ್ಸೋ ಕಾಲ್ಡ್ ಆಸ್ ನ್ಯೂಟನ್ಸ್ ಎಕ್ಸ್ಪೆರಿಮೆಂಟ್. ಟಿಂಡಾಲ್ ಎಫೆಕ್ಟ್. ವಾಟ್ ಇಸ್ ಟಿಂಡಾಲ್ ಎಫೆಕ್ಟ್? ನೋಡಿ, ಲೇಸರ್ ಲೈಟ್ ಗ್ಲಾಸ್ ಅಲ್ಲಿ ಹಾಲು ಹಾಕಿದ್ದೀನಿ, ಒಂದಲ್ಲಿ ನೀರು, ಒಂದಲ್ಲಿ ಹಾಲು. ಲೇಸರ್ ಲೈಟ್ ಏನಾಗ್ತಿದೆ? ಫುಲ್ಲು ಅಲ್ಲಿ ರೆಡ್ ಕಲರ್ ಸ್ಕ್ಯಾಟರ್ ಆಗ್ತಿದೆ. ಇಲ್ಲಿ ನೋಡಿ, ಬೆಳೆಯೋತ್ತು ಕಾಡಲ್ಲಿ ಹೋದ್ರೆ ಎಲ್ಲ ಲೈಟ್ ರೇಸ್ ಎಲ್ಲ ಒಳಗಡೆ ಬರ್ತಿದೆ, ದಾರಿ ಕಾಣಿಸಿದೆ ಲೈಟ್. ಸೊ ದಿಸ್ ಸ್ಕ್ಯಾಟರಿಂಗ್ ಆಫ್ ಲೈಟ್ ಸ್ಕ್ಯಾಟರಿಂಗ್, ಬಿಕಾಸ್ ಆಫ್ whom? Because of the colloidal particles. That phenomena is called as Tyndall effect. Scattering of light by dust particles ಅಂತ ಬರೀಬಾರ್ದು, colloidal particles. ಇದಾಗಲೇ ಎಕ್ಸ್ಪ್ಲೇನ್ ಮಾಡಿದೆ. ಅದು ರಿಯಲ್ ಲೈಫ್ ಎಕ್ಸಾಂಪಲ್ಸ್ ಇದನ್ನ ಕೇಳ್ತಾರೆ. ಏನೋ ಇದರಲ್ಲಿ ಇದೆಲ್ಲ ಏನದು, ಕಾಡಲ್ಲಿ ಹೋದ್ರೆ ಕ್ಯಾನೋಪಿ ಇನ್ ದ ಡೆನ್ಸ್ ಫಾರೆಸ್ಟ್, ಯು ಆರ್ ಗೋಯಿಂಗ್ ಇನ್ ಎ ಕಾರ್ ಇನ್ ದ ಮಿಡ್ ನೈಟ್, ದಿಸ್ ಎ ಕೋಲ್ಡ್ ವಿಂಟರ್ ಸೀಸನ್, ಯು ಕ್ಯಾನ್ ಸಿ ದ ಪಾತ್ ಆಫ್ ಲೈಟ್. ಹೌ? ಬಿಕಾಸ್ ಆಫ್ Tyndall effect. Okay. What is this wavelength? Again, I'm explaining the wavelength. Why you want to, if you understand this, you can answer the give reason. ಇಲ್ಲೇನಿದೆ? ರೇಡಿಯೋ ವೇವ್ಸ್, ಮೈಕ್ರೋವೇವ್ಸ್, ಇನ್ಫ್ರಾರೆಡ್, ಅಲ್ಟ್ರಾಲೈಟ್, ಎಕ್ಸ್ರೇಸ್, ಏನಿವೆಲ್ಲ? ನಮಗೆ ಕಾಣಿಸೋದು ಬರೇ ಇಷ್ಟು ಕಲರ್ಸ್. ನಮಗೆ ವಿಸಿಬಲ್ ಲೈಟ್ ಮಾತ್ರ ಕಾಣಿಸೋ. ಅದು ಬಿಟ್ಟು ನಮ್ಮ ಸುತ್ತಮುತ್ತಲು, ಇವಾಗ ನಾನು ಕ್ಲಾಸ್ ರೂಮಲ್ಲಿ ಕೂತಿದ್ದೀನಿ, ಇಲ್ಲಿ ರೇಡಿಯೋ ವೇವ್ಸ್ ಇದೆ, ಮೈಕ್ರೋವೇವ್ಸ್ ಇದೆ, ಇನ್ಫ್ರಾರೆಡ್ ಇದೆ, ಗಾಮಾ ಇದೆ, ಅಲ್ಟ್ರಾವೈಲೆಟ್ ಇವಾಗಿಲ್ಲ ಬಿಡಿ, ಅದೆಲ್ಲ ಇರುತ್ತೆ ಬೆಳೆಯೋತ್ತು. ಅದೆಲ್ಲ ಕಣ್ಣು ಕಾಣಿಸುತ್ತಾ? ಕಾಣಿಸುತ್ತೆ. ನಮ್ಗೆ ಕಾಣಿಸೋದು ಬರೀ ವಿಸಿಬಲ್ ಲೈಟ್ ಮಾತ್ರ. ಆದ್ರೆ ನಾಯಿ, ಬೆಕ್ಕು, ಅದಕ್ಕೆಲ್ಲ ಇನ್ಫ್ರಾರೆಡ್ ಕಾಣಿಸುತ್ತೆ ರಾತ್ರಿ ಹೊತ್ತು. ಆಯ್ತಾ? ಸೊ ದಿಸ್ ಇಸ್ ದ ಟೈಪ್ಸ್ ಆಫ್ ರೇಸ್. ಬಟ್ ಫಾರ್ ಅಸ್ ವಿಸಿಬಲ್ ಲೈಟ್ ಮಾತ್ರ ಸಾಕು. ವಿಸಿಬಲ್ ಲೈಟ್ ಅಲ್ಲಿ 7 ಕಲರ್. ಆ 7 ಕಲರ್ ಅಲ್ಲಿ ರೆಡ್ ಜಾಸ್ತಿ ವೇವ್ ಲೆಂತ್, ಒಂದೊಂದು ಕಲರ್ಗೂ ಒಂದೊಂದು ವೇವ್ ಲೆಂತ್ ಇದೆ. ಇದು ಅದ್ರ ಟೇಬಲ್. ನೆಕ್ಸ್ಟ್ ರೆಡ್ ಕಲರ್, ದಿಸ್ ಆಲ್ರೆಡಿ ಐ ಟೋಲ್ಡ್ ವೈ ವಿ ಯೂಸ್ ಡೇಂಜರ್ ಸೈನ್. ನೋಡಿ, ವೇವ್ ಲೆಂತ್ ಜಾಸ್ತಿ, ತುಂಬಾ ದೂರ ಹೋಗುತ್ತೆ. ಓಕೆ, ದಟ್ ಇಸ್ ವೈ ವಿ ಯೂಸ್. ಇವಾಗ ಬರೋಣ. ಸ್ಟಾರ್ಸ್ ಟ್ವಿಂಕಲ್ ಆಗುತ್ತೆ, ಪ್ಲಾನೆಟ್ಸ್ ಟ್ವಿಂಕಲ್ ಆಗಲ್ಲ. ಡಯಾಗ್ರಾಮ್ ನೋಡ್ರೆ ನೀವೇ ಆನ್ಸರ್ ಮಾಡ್ಬಿಡ್ತೀರಾ. ಸ್ಟಾರ್ಸ್ ಇಂದ ಬರೋದು ಒಂದು ರೇ ಆಫ್ ಲೈಟ್. ಲೇಸರ್ ಲೈಟ್ ಆನ್ ಮಾಡಿದ್ರೆ ಒಂದು ಲೇಸರ್ ಲೈಟ್ ವಿಲ್ ಕಮ್, ನೋ ಒನ್ ರೇ. When it is coming in atmosphere, different molecules, different layers, ionosphere, mesosphere, that the stratosphere, ionospheres, materials. What will happen to the beam of light? It bends and come to our eyes. What happens? ನೋಡಿದಾಗೆ on off ಅಂತಿರುತ್ತೆ. ಬಟ್ ಪ್ಲಾನೆಟ್ಸ್ ಇಂದ ಬಂದು ಟಾರ್ಚ್ ಲೈಟ್ ಆನ್ ಆಫ್ ಆಗಲ್ಲ, ಬಿಕಾಸ್ ಇಟ್ ಇಸ್ ವೆರಿ ಕ್ಲೋಸರ್ ಟು ಅರ್ತ್. ಓಕೆ, this if you understand in your own words, okay, try to understand in your own words and understand and write it in your own words. Okay. ರೇನ್ಬೋ ಹೆಂಗಾಗುತ್ತೆ? ರೇನ್ಬೋ ಯಾರು ಪ್ರಿಸಮ್ ಇಟ್ಟಿದ್ದಾರೆ ಆಕಾಶದಲ್ಲಿ? ಇಲ್ಲ. ಏನಿಟ್ಟಿದ್ದಾರೆ ಮತ್ತೆ? ನಾವು ಇಟ್ಟಿರೋದು ವಾಟರ್ ಡ್ರಾಪ್ಲೆಟ್ಸ್. ವೆನ್ ರೇನ್ ಕಮ್ಸ್, there is sunlight, you get a rainbow. Where does the rainbow comes? Opposite to the sun. So what happens? White light comes. What is the first thing that happens? Remember this process. There are tiny water droplets in the sky which acts like the prism. When the sunlight hits these tiny water droplets, first thing refraction, then dispersion, then total internal reflection, then again refraction, then again to your eyes. This back-to-back principle you have to know and write this step 1, step 2, step 3, refraction, dispersion, total internal reflection, final refraction. Last one, why sky is blue? ಆಕಾಶ ಯಾಕೆ ಬ್ಲೂ ಆಗಿದೆ? ಯಾಕೆ ಬೇರೆ ಕಲರ್ ಆಗಲ್ಲ? ಎಷ್ಟೊಂದು ಕಲರ್ ಇದೆಯಲ್ಲ, ಯಾಕೆ ಎಲ್ಲ ಆಗಲ್ಲ? If you see the three colors which are bending the most, violet, indigo and blue, our eyes is sensitive to these colors. ನಮಗೆ ಬ್ಲೂ ಮಾತ್ರ ಆಕ್ಚುಲಿ ಸ್ಕೈ ವೈಲೆಟ್ ಗೊತ್ತಾ ನಿಮ್ಗದು? ಸ್ಕೈ ಆಕ್ಚುಲಿ ವೈಲೆಟ್ ನಮಗೆ ಕಾಣಿಸಲ್ಲ, ಬ್ಲೂ ತರ ಕಾಣಿಸುತ್ತೆ. ಎನಿಯೋ ವೈ? Since this blue light has lesser wavelength, smaller wavelength, so small, there are so smaller particles in the atmosphere. When this blue light hits, shadrogutte, it scatters away. That scattering, when you see the sky, it becomes blue color. In your own words, see, the molecules in the air and fine particles in the atmosphere are smaller than visible light, are very smaller. Okay, so when these fine particles in the atmosphere are effective in scattering whom? There are fine particles where? There are fine particles in the atmosphere. They will scatter whom? They will scatter the shorter wavelength blue color. They will not scatter red color because red is far wavelength. It will go very, very far. Okay, it will not dash them. Who will dash these fine particles? The blue the blue light will dash. So dashing, scatter, Tyndall effect. Okay, the really scattering anta higher classes allo othira bitbidi. That thing, same thing, point wise, just go through and understand this. So that's all. Thank you.